connecting, but they have been resolved now. Today we are going to discuss 8051 programming in C. Yesterday's class we have seen the architecture of 8051 and also we have seen the different programming languages which are used. As I already told you that the most widely used programming languages for 8051 is C. And the reasons for that also we have discussed yesterday. In today's class, we will be doing more programs of C for 8051 as well as I will be telling you about Keel compiler. As I told you that although we write our program in a high level language, but the controller it does not understand that. It understands only the machine language, that is the hex file. So in order to convert this C file into the hex file, we require a compiler. So the most popular one for 8051 is Keel compiler, and that we are going to discuss today. I hope all the centers they have downloaded Keel compiler because it will be easier for you to practice simultaneously what I'm telling you. And also I'm going to give you one assignment of C programs by the end of today. And please, all of you are requested to send it back to me by Thursday. The Thursday class, first 15 minutes or 20 minutes, we'll be keeping for discussing those questions. Please take it seriously because only those centers who submit me the assignments, I'll be giving the certificate. Another thing is that I can, in some of the centers, I can see very less participation. Harjot, can you do, put that Madurai center? There's no one there. Anna University, Madurai. Anna University, Madurai, I'm going to disconnect your center as I cannot see any participants there. And I will not be providing you the certificates. See, we have told you in the yesterday class itself that if there is no participation, I'm not going to give you certificates. Okay. So let's begin the class. Yesterday I was telling you about the various data types. You know why it is very important to select the right data type for your program? That is because we have limited on-chip memory, right? So limited on-chip memory, each data type, it consumes a particular bytes of memory. For example, the one which we discussed yesterday, character data type, it consumes 8 bits of memory or 1 byte of memory, and it is used in case of those variables where in case of those values which have the value between 0 to 255. Okay, so let us discuss one example. It will give you more idea about what I was telling you. For example, this is the problem statement. Write an 8051 C program to send values 00 to FF to port P1, right? So as you can see in this screen, we have this header file hash include reg51.h, then void main void, and in these curly brackets we write our main program. So the first thing which you have to keep in mind is that because the values are in the range 00 to FF, that means 00 to 255 decimal. So we have to select one variable and give it a name. Now for selecting that variable, we have to see which particular data type. As in this case, the value is from 0 to 255. In yesterday's class, we have seen that for values between 0 to 255, the data type to be selected is unsigned char, right? So that's why I have taken one character variable Z. I've given it a variable Z. You can give it any name. Okay? So unsigned char Z. That is the first thing which you have to do. You have to be very careful in selecting this particular data type. And then we use a for loop here. Which values are to be sent to P1? So Z values are to be sent to P1. So that is why this is P1 is equal to Z. So the whatever value the Z has, it will be assigned to P1. Okay. Now, because the values 0 to 255 are to be given to P1, so that is why we take a for loop and we initialize Z with 0. We increment it and then we maximum value till which the for loop should go is Z is less than equal to 255. So what will happen is that the initially value 0 will be given to Z, then 0 will be transferred to P1, then 1. As it keeps on incremented one by one, the values they will be sent to P1. So this is the simple example of writing 8051 C program wherein I am giving values 0 to 255 and we are sending it to P1. Okay, any doubts? It's clear. So very simple program. Now this is another program in which you have to see, in this you have to toggle all the bits of port P1. So toggle means if whatever value was 0, make it 1, whatever value was 1, make it 0. So in the main program, what they've done is they've chosen any one value. You can choose any value of your choice. In this case, I have taken 0x55. Yesterday I told you that 0x represents hexadecimal. So 55h value, that means in decimal, in binary it is 01010101, and if we toggle 01010101, it becomes 101010. Okay, and that in hexadecimal it is 0xAA. So that is why what we did is initially I said P1 is equal to 0x55, and then I toggle it and I put it 0xAA. You can take some other values also. For example, I can make it initially 00, and I want to make 0 as 1. So what will be the value after toggle it? It will be FF. Okay, it's very simple. So it can be like suppose, as I told you yesterday, that suppose you have in port 1 there are 8 LEDs connected, and you want that whatever LEDs they were on, they should be off. They should be off. So initially whatever value was 0, it becomes 1. Now suppose this program, it will run only once, right? Now suppose you want to keep on repeating this particular process continuously forever. Now what to do in that case? Now my problem statement, it will change. It will be toggle all the bits of port P1 continuously. For that, simple, I have to use a empty for loop. That's it. And whatever operation you want to perform continuously, just put it in the curly brackets. So this particular operation I want to repeat continuously. So what I do is I put it in curly brackets and I put a empty for loop. So this particular operation, it will be repeated continuously forever. Yeah, you can use while one also. Instead of this empty for loop, you can use while one also. This will also do the same thing. In case you have any doubts, you can ask me. अगर किसी भी सेंटर को कोई भी डाउट है जब मैं करवा रही हूँ तो आप साथ के साथ भी पूछ सकते हैं हमसे, ठीक है? Because this is the base of the C programming which we are going to do today. Because in the second class also you will be doing more real world interfacing programs. Now, for example, it will be LCD, keyboard, motors, etc. But if you don't know the basics of C, then you will not be able to understand those programs. So it is very important to understand how. That is why I am beginning step by step with a simple program. Okay. Now, up till here, we have done the character data type, whose value was from 0 to 255. Now, what if you want more than 255? You cannot use character in that case. ठीक है ना? Suppose you want to send the value 00 to FFFF to port to something, anything, और किसी भी ऑपरेशन में आपको 255 से ज्यादा वैल्यू चाहिए, तो उस केस में you cannot use the character data type. In that case, we make use of the int data type, integer. ठीक है? So just like character was 8-bit, int is a 16-bit, यानी कि 2 bytes. And 2 raised to power 16, that means its value ranges from 0 to 65535. So for those variables whose value ranges from the value 0 to 65535, we prefer to use, or in fact not prefer, we have to use integer. So similar to your character, the int is also of two types. One is unsigned, the other is signed. Unsigned is for positive numbers whose value ranges from 0 to 65535, and signed is for negative number 377635. मतलब इसका हाफ कर लीजिए आप. तो साइन नंबर्स जो होते हैं जहां आपके पॉजिटिव और नेगेटिव नंबर्स दोनों है वहां पे आपका साइन इंट यूज होगा. ठीक है, बट हाउ एवर इट टेक्स 2 बाइट्स ऑफ मेमोरी. Now tell me one thing. Suppose the previous example itself, which we did. In this case, suppose instead of this char, if I used int, will it show an error? The same program which we did earlier, write an 8051C program to send value 00 to FF to port P1. Earlier I had taken the character data type, unsigned character data type. Now what I did is that instead of character data type, I have written int. Now my question is, will it show an error? It should not show an error because value 255 is included in the range 0 to 65535. However, I should not use it. एक चीज है, it will not show an error. However, I should not use this. Why? Because when you can use a character, why to use int? Character, as I said, it takes only 1 byte of memory, whereas int takes 2 bytes of memory, and we have limited on-chip memory. So this is the reason I was telling you that it is very important to select the right data type. Clear? But in case you have a value more than 255, in that case you cannot select a character. You have to take int. Right? Clear? So we will see one example in which int is used. Now suppose this is the situation. That is, you have to write an 8051C program to toggle port P1 50,000 times. Now in this case, how many times you have to repeat a particular operation? 50,000 times. So this 50,000 value is more than 255. So आपको इसके लिए एक वेरिएबल लेना पड़ेगा, वेरिएबल डिफाइन करना पड़ेगा, और उसके लिए डेटा टाइप विच यू विल सिलेक्ट इज इंट, है ना. So it's simple. Header file void main void, and then you take one integer z, unsigned int, one variable unsigned int z, and then we apply a for loop for z is equal to 0, z is less than 55, 50,000, z plus plus, and the operation which you want to perform is to toggle it 50,000 times. In this case you will use it. Okay, this is how you will use the int. Now this character data type, int, float, etc., these are the same which you use for C also. आपकी जो टर्बो सी कंपाइलर में आप करते हो वही सेम इसमें भी है. बट देर इज वन मोर डाटा टाइप विच इज स्पेसिफिक ओनली फॉर 8051. दैट डाटा टाइप इज नोन एज एस बिट. Yesterday I told you that there is one feature of microcontroller which is its advantage over microprocessor is its single bit addressability, right? So single bit addressability का मतलब क्या हुआ कि जहां पे आपका एक single bit रहता है उसको कैसे define करेंगे. Now in your header file, this hash include reg51.h. All your ports are defined. All your special function registers are defined. Your timers are defined. Your serial port registers, they are all defined. However, your single bits, they are not defined here. For example, P1.0. P1 2.5, they are not defined. उनको define करने के लिए आप एक तो one thing is that you have to define them globally, and the variable which we use is s bit. Now let us see the syntax. This is the syntax. S bit means single bit. Wherever you have to use a single bit, you will use a S bit data type. For example, P1.0, and yesterday itself I told you that for in case of C language, you will not say P1.0, you will use P1 asterisk 0. Suppose the situation is like this, that in your port pin P1.0, one LED is connected, right? And that LED you have to alternatively glow on or off. Now in case of port P1 there was no difficulty. You simply wrote P1 is equal to 0x55, P1 is equal to 0x AA. It accepted it. The compiler accepted it because in the header file P1 was defined. The address of the P1 was also defined in the header file itself. But as I said, in case of P1.0 it is not defined. So you have to define it by the use of S bit. Syntax is S bit, you give it a name. In this case, I have given it a name LED. To make it simple, you have connected an LED in this case, so just make it LED. If you, अगर आपको अपना नाम बहुत अच्छा लगता है, आप अपना नाम दे दो. कंपाइलर को कोई दिक्कत नहीं है इस चीज से. आप अपना नाम भी दे सकते हैं इसमें, ना. बट बेटर रहता है कि जो चीज उसके साथ कनेक्टेड आपको प्रोग्रामिंग में थोड़ा इजी रहेगा. तो सिंपल है, एस बिट डाटा टाइप देन एलईडी वट एवर नेम यू गिव इज इक्वल टू वट एवर पोर्ट पिन. अब मेन प्रोग्राम में, और इसको आपने कहाँ डिफाइन करना है एस बिट को? ग्लोबली. ग्लोबली मीन्स बिफोर योर वॉइड मेन वर्ड, यानी हैश इंक्लूड reg51.h के बाद में आप s bit led is equal to p1 steric 0 करेंगे. उसके बाद यस दिस पर्टिकुलर डाटा टाइप s bit, बाकी नहीं. बाकी तो आप मेन प्रोग्राम में लिखोगे. तो अब इसके बाद में आप अपने मेन प्रोग्राम में led का ही नेम यूज करोगे. यू विल नॉट राइट p1 steric 0. सो ऑटोमेटिकली जहां पे भी आपका वर्ड led आएगा, इट विल टेक इट एज p1 steric 0. Clear? Now let us see one. Is there any doubt? No? Okay. So now let us see one example. Write an 8051C program to toggle port P1 50,000 times. So we have already seen in order to toggle something 50,000 times, we have seen the use of unsigned int. But in this case, there is port bit D0 of port P1. अब यहाँ पे हमारा सिंगल बिट यूज हो रहा है, कौन सा? P1 स्टैटिक 0. तो इसलिए सबसे पहले इसको हम ग्लोबली डिफाइन कर रहे हैं एस बिट. वी हैव गिवन इट अ नेम माय बिट is equal to P1 static 0. So these are the comments. In case of C, the comments are given by these inverted lines. So whatever you write after these inverted lines, that is taken as a comment. So void main void unsigned int Z. This is for repeating this particular operation 50,000 times. And in order to toggle it, what we do is, यहाँ पे 1 है. What we do is simple. ये अब सिंगल बिट है, इसलिए 0 and 1. यहाँ पे आपने ऐसे नहीं लिखना y bit is equal to 0x55, बिकॉज आपका यहाँ पे सोर्स क्या है? सिंगल बिट, और डेस्टिनेशन भी सिंगल बिट ही होनी चाहिए. तो माई बिट अगर आपका सिंगल बिट है तो आपका 0 आएगा. उस केस में पोर्ट P1 क्या था? 8 बिट्स का था, इसलिए आप 8 बिट का डाटा दे रहे थे. क्लियर? So this is how we make use of the various data types. So we'll do some more examples. थोड़े से examples हम और करते हैं, और उसके बाद में we will see that once we've written our program in C, then how to convert it into a hex file. And you will get more practice because in the second class also sir will be telling you about real world interfacing programs. उनके भी C language के प्रोग्रामिंग करेंगे, उससे आपको और ज्यादा क्लियर हो जाएगा. ठीक है? नाउ अभी तक तो हम क्या कर रहे थे? वी टॉगल्ड बिट्स P1 कॉन्टिन्यूसली के लिए भी हमने देख लिया, एम्प्टी फॉर लूप लगाना है सपोज. बट यही ऑल्टरनेटिवली ग्लो करने के लिए. बट सपोज यू वांट टू इंक्लूड सम डिले इन बिटवीन. ठीक है? अभी कैसे था कि सपोज पोर्ट P1 पे हमारी एलईडीज लगी हुई है. ये बोर्ड यूज करना है. Now suppose 8 LEDs are there at port P1 and our requirement is that we want to alternatively glow the LEDs. Okay, so yearly suppose what is this AA? So हमारा प्रोग्राम कैसे रहेगा? दिख रहा होगा हमको डन राइटिंग. Now what I want is कि हमको इसको alternatively glow कराना है. Simple P1 so if this becomes off, it will be 0 1 0 1 0 1 0 1 and this is nothing but 0x55. But आप जब इसको change करेंगे, you will not be able to see this difference. So what I want is that when you alternatively glow these, there should be a delay in between. So delay के लिए हम क्या कर सकते हैं? हम simple एक for loop लगा लेते हैं. For loop क्या करेगा? इसके लिए हम क्या करते हैं? पहले एक unsigned int x. We take one variable unsigned int x and we simply apply a for loop in between. Now what will this for loop do? I have initiated with 0 and it will be incremented and it will keep on going to 40,000. वो क्या करेगा कि 40,000 तक increment हुआ 0 1 2 3. It will take some time and this will be nothing but your day. Now suppose I want this particular operation to be repeated forever. What I will do is I put this in curly brackets and I use one empty for loop. And for because once it becomes this, it is toggled. Again, it has to toggle from here. So that is why here also I will require again one. What will happen here is initially your values will be 10 10 10 10. There will be some delay. It will be toggled to 55. There will be one delay. Once it becomes from here to here again, so this will keep on repeating continuously. Okay. Now you have to answer me one thing. Yeah. You can change the delay by changing the value of your for loop. For example, if you say 20,000, your delay will be decreased. If you say 55,000, your delay will be increased. Now, my question to the participants of the different centers is, what is the significance of this semicolon here? What if I do not apply this semicolon after this for loop? Will it show an error? Will it show a syntax error? Yes. They are answering. Anyone from Madurai? My question is that in the for loop, if you do not apply the semicolon in the end, will it show an error? Next center. Anyone from RTU Kota?
Hello.
Yes, sir.
मैम वो ऐड हो जाएगा कंडीशन को इनफाइनाइट
क्या कह रहे हैं सर?
मैम अगर हम सेमीकोलन ऐड पे लगाएंगे तो हमारा टर्मिनेशन हो जाएगा कंडीशन इनफाइनाइट लूप तक जो हमने कंडीशन की मतलब लूप नहीं चल पाएगा.
नहीं सर, इनफाइनाइट लूप की बात नहीं मैम कर रहे हैं. इनफाइनाइट लूप तो चलेगा बिकॉज आपने एम्प्टी फॉर लूप लगाया है. मेरा क्वेश्चन है कि जो आपने फॉर लूप x इज इक्वल टू 0, x इज लेस देन 40,000, x प्लस प्लस के एंड में मैंने यहाँ पे एक सेमीकोलन लगाया है. आप अगर ध्यान देंगे, इससे पहले वाला जो प्रोग्राम था, जब मैंने किसी पर्टिकुलर ऑपरेशन को रिपीट कराना था 40,000 टाइम, वहां पे मैंने सेमीकोलन नहीं लगाया था, यहाँ सेमीकोलन क्यों लगाया है? और अगर यहाँ पे मैं सेमीकोलन नहीं लगाती हूँ तो क्या होगा? सिंटेक्स एरर देगा। नेक्स्ट सेंटर, सुरेंद्र इंस्टीट्यूट,
Yes, from pipe.
पानीपत इंस्टीट्यूट, एनीवन फ्रॉम हियर? नहीं वो तो हाँ, नहीं, इफ आई डोंट पुट सेमीकोलन देन दैट्स राइट। हाँ हाँ, तो डिफरेंट इंस्ट्रक्शंस नहीं बनेंगे आपकी। सेमी कॉलन लगाने का मतलब क्या है कि आपकी वैल्यू x इज इक्वल टू 0 है, फिर 1 है, फिर 2 है, लेकिन नेक्स्ट इंस्ट्रक्शन का उससे कोई लेना देना नहीं है, बिकॉज वो सेमी कॉलन आपने जब लगा दिया तो वो स्टेटमेंट टर्मिनेटर वहां पे हो गया। लेकिन अगर आप ये सेमी कॉलन नहीं लगाते हैं तो क्या होगा? आपका पहले x इज इक्वल टू 0 है तो P1 के अंदर 0x AA आएगा, फिर x इज इक्वल टू 1 है, फिर वो आएगा, तो वो जो नेक्स्ट स्टेटमेंट है दैट विल बी इंक्लूडेड इन योर फॉर लूप। So that is the significance of putting a semicolon. सी लैंग्वेज में आपको छोटी छोटी ये चीजें होती हैं जिनका आपने ध्यान देना है। फॉर लूप लगा दिया, सेमीकोलन नहीं लगाया, वो आपको डिले नहीं दे रहा, वो आपका उस पर्टिकुलर ऑपरेशन को उतनी बार रिपीट कर देगा। So wherever we have to repeat a particular operation number of times, we will not use a semicolon because next statement will be included in that. And in that case जहां पे आपको उसको डिले देना है वहां पे आप उसका सेमीकोलन करेंगे। अब लेकिन यही वाला क्वेश्चन था जो इससे पहले नहीं नहीं, इट्स नॉट अलाउड, नहीं, वो इसने बाय डिफॉल्ट ले लिया है इसमें वर्ड पॉइंट में। अब इस क्वेश्चन में देखिए जो इससे पहले वाला था, टू टॉगल बिट D0 पोर्ट P1 50,000 टाइम्स। सपोज आई डोंट पुट दिस कर्ली ब्रैकेट हियर, now what will happen? I have removed the curly bracket here. Will it show an error? क्या होगा ऑपरेशन, क्या आउटपुट क्या होगा आपका? No, it will not remain same. Because अगर आप इसके एंड में सेमीकोलन नहीं लगाते हैं तो आपका जो नेक्स्ट स्टेटमेंट है दैट विल बी ओनली इंक्लूडेड इन दिस। Why I had put, yes, earlier it was like this. What is the meaning of this? That these two statements are included in for loop. But if I remove this, then only this my bit is equal to 0 will be included in this. So what will happen is that the same thing. My bit is equal to 0 ही आपकी 50,000 times repeat हो जाएगी. Wherein you have to repeat a particular more than one instruction, किसी particular उसमें you will put a curly brackets. Now this is another statement. Get a byte of data from P0. If it is less than 100, send it to port P1. Otherwise, send it to port P2. अब इसमें आपको एक और चीज मैं बताती हूँ कि आपके पोर्ट्स जो हैं, what are they? They are either input or output. है ना? What we are saying, input or output, input output ports. By default, they all are output ports. But in order to make them input ports, you have to write 1111 on all the ports. This is compulsory. I'm saying that your ports are either input or output, right? आउटपुट के लिए का मतलब क्या है कि जैसे आपने उसके ऊपर कुछ आउटपुट डिवाइस लगाया, एलईडी लगाया है या एलसीडी लगाया है, 7 सेगमेंट डिस्प्ले लगाया है, बजर लगाया है, रिले लगाया है, कुछ भी आउटपुट डिवाइस अगर आपने लगाया है तो वो एक आउटपुट डिवाइस, आउटपुट पोर्ट की तरह ही उसको बताना नहीं पड़ेगा दैट यू हैव टू बिहेव लाइक एन आउटपुट पोर्ट, लाइक इन अर्लियर केसेस। इससे पहले वी हैड पुट सम एलईडीज, वी डोंट डू एनीथिंग एक्स्ट्रा, But suppose in this case, the statement is get a byte of data, means some real time data is coming at P0. Suppose there is some sensor at port P0. So you have to get a byte of data from P0. You have to make port P0 an input port. And how will you make this port P0 an input port? You will write 111111 on the port P1. So what will be the statement for that? P0 is equal to 0xFF. So initially you will write P0 is equal to 0xFF. That is to define port 0 as an input. That is the first thing you have to take care. So जहां पे भी आपको ऐसे दिया हुआ ना, get a byte of data means by default there is some sensor connected, some data, real time data is coming, and you have to make port 0 an input port. So in this case, as you can see from here, P0 is equal to 0xFF. Why is it done? It is to make this an input port. And we also, हम क्या करेंगे, continuously monitor कर रहे हैं क्योंकि वो data continuously आ रहा है. So by default we apply one empty for loop also. उसके बाद हमने क्या करना है? अच्छा, some data is coming. तो आपको उस डाटा के लिए एक वेरिएबल लेना पड़ेगा. P0 में सम डाटा इज कमिंग. आप ऐसा, बिकॉज अगर हमने क्या करना है, उस डाटा को कंपेयर करना है किससे, 100 से. अगर उसकी वैल्यू 100 से लेस है तब आपको उसको भेजना है किसमें, P1 में. अगर ज्यादा है तो आपको उसको P2 में भेजना है. तो हम ऐसा नहीं कर सकते हैं कि P1 इज इक्वल टू P0. दैट इज नॉट अलाउड. दिस इज नॉट अलाउड. सो व्हाट वी डू इज, इंस्टेड वी टेक वन वेरिएबल. उसको हमने नाम दे दिया इंट माई बाइट. वैसे इंट देने की जरूरत नहीं है, हम यहाँ पे कैर देंगे बिकॉज यू हैव अ बाइट ऑफ डेटा. सो वी विल नॉट यूज इंट, वी विल यूज अ कैर. So I have taken one character my byte. What I do is whatever value is coming in P0, it is assigned to my variable my byte. Then I use an if statement because I have to compare it with 100. So if my byte is less than 100, where I have to send P1. So what is the destination now? P1. So P1 is equal to my byte. Else P2 is equal to my byte. That's it. Clear? These were some of the programs. There are many more programs also, but at least to give you basic idea about how to write your program in C, I have told you. So what we have seen is, we have seen the various three types of data types mainly. One is character, unsigned char, unsigned int, signed int, and your S bit. And we know that S bit is to be declared globally. तो जहां पे भी आपका सिंगल बिट यूज हो रहा है वहां पे आपने एस बिट को यूज करके, एंड यू हैव टू यूज दैट पर्टिकुलर नेम इन योर मेन प्रोग्राम. यू विल नॉट से P1 स्टार x0 इन दिस केस. P1 स्टार x0 आपने इनिशियली डिफाइन कर दिया एस बिट के लिए. देन वी सॉ कि अगर हमको किसी भी पर्टिकुलर लूप को या पर्टिकुलर ऑपरेशन को कंटिन्यूअसली परफॉर्म कराना है, सो देयर आर टू वेज. वन इज यू कैन यूज एन एम्प्टी फॉर लूप और यू कैन यूज अ while one, right? So suppose you have to repeat a particular operation number of times. So what we do is we use a for loop and just operation को कराना हम उसको उसमें इंक्लूड कर देते हैं. ठीक है. एंड देन वी हैव आल्सो सीन कि हमारा अगर रियल टाइम डाटा आ रहा है तो हमको उसको पहले पोर्ट को इनपुट डिफाइन करना पड़ेगा. हाउ डू वी डिफाइन? बाय राइटिंग 1 इन ऑल द पोर्ट बिट्स, एंड दैट वी डू इज P0 is equal to 0xFF. Okay. And then if and else statement also we have seen. If you have any doubt till here, you can ask me, because after this I will be telling you how to convert this C program into hex file by using the Keel compiler. So if any of the center has any doubt, please ask me. No, Keel is not case sensitive. You can write your program in small or you can write your program in capital. हेक्साडेसिमल डाटा जब आपने लेना तो प्रेफर करो उसको स्मॉल लिखना. Any other doubts? Clear? Microvision is the company. This is the IDE, Integrated Development Environment of C. Keel compiler. So as you can see from here, there are various windows. This is the toolbar wherein just like file, etc. This is the project window. Whatever project you make, that comes in this project window. And this gray space, as you can see from here, this space is basically wherein you write your program either in C or in assembly. Keel compiler can be used to program both. Yeah, as an editor for both, for assembly as well as C. Right now it is disabled, but whenever we write a program, it will become white in that case. And this is one output window. जो भी आपका errors आ रही हैं या successfully आपका program build हो गया है, so all those things they will come in this build output. Okay. Well, let us take a very simple program initially. So first thing which you have to take care is go to project, new microvision project. Then you have to select one destination. Your various files will be built up, linked file, object file, etc. So it is always advisable कि आप एक folder बना लीजिए, उसमें folder में आपका सब रहेगा. So let's say desktop पे हम एक folder बना लेते हैं. Give it a name. Let's give it a name. Let's say LED. Open. This is the name of the folder. The name of the project also I give LED. And then I say save. Now this is very important that you have to select the right type of microcontroller in this case. जो भी माइक्रो कंट्रोलर आप ले रहे हो उसी के हिसाब से हेक्स फाइल बनेगी. अगर आपने रॉन्ग माइक्रो कंट्रोलर यहाँ पे ले लिया तो हेक्स फाइल आपकी रॉन्ग हो जाएगी. सो बी वेरी केयरफुल. फॉर एग्जांपल हमारा एटमेल का ही है. Let's say 80 Atmel 89. I told you yesterday 89 stands for flash memory. C is the CMOS technology and 51 is the MCS family. So when you select it in the description, you get all the description also about this microcontroller, particular microcontroller, and then you say OK. So it will ask you copy startup file. You can say yes. So as you can see from here, now a project has been made. पहले project window was blank earlier, but now a project has been made with the name LED. Now we will write our main program. So for that, either you can go to here new or you can say file new. So here we will write our main program. We begin with comments. Upload directly मतलब हाँ ओपन करके कर सकते हो आप यहाँ से फाइल ओपन करके भी कर सकते हो. So my program is to glow alternate LEDs continuously. So this is the program I've written. Hash include, this is the header file, void main void for empty for loop for continuous operation, and P1 is equal to 0x55, and then P1 is equal to 0xAA, and then I close the loop. Okay. The next step is we have to save this program. So again, I will go to either this or we can go to file save also. So when we say save, it will go to the same destination. Now I give it a name, let's say LED. One thing now here you have to take care is that whatever format you are writing your program, whether you're writing your program in C or you're writing your program in assembly, you have to give the extension for the same. For example, in case you're writing your program in assembly, you will say led.asm. In case you're writing your program in C, you will write led.c. In this case, it is led.c. Then you say save. So can you see the difference now? Once you have saved it, it has changed colors. Your comments, they have become green in color. Your header file has become some magnifier. कहाँ पे मैग्नीफायर कैसे आता है? अभी देख रहा है? So can you see this? The centers? एक बार इनको पूछ लेते हैं.
Hello.
हाँ जी.
Hello.
Yes sir.
Ma'am, it would be better if you increase the font size of the text.
क्या कह रहे हैं?
सर ये हम वही कर रहे हैं सर, वी आर
तो
डूइंग
वही
इट.
वही ट्राई कर रहे हैं मैग्नीफाई करने की ना उसको.
Okay. So,
एक और काम करते हैं, रुको एक काम और करते हैं. मैं इसको वर्ड फाइल में ले जाके वहां पे इनको प्रोग्राम ही देखना है ना मेन.
अगर इसमें नहीं आप फॉन्ट साइज बढ़ा सकते.
इसमें नहीं है, कील में ऐसा ऑप्शन नहीं है. ये हम पहले भी किया हुआ है ना, जब भी कील का आता. व्यू में नहीं, व्यू में भी नहीं होगा. यहाँ जाओ. चलो इन्होंने प्रोग्राम तो देखा ही हुआ है. प्रोग्राम तो आपने ऑलरेडी देखा ही है ना. वही वाला प्रोग्राम है ये, टू ग्लो alternate LEDs at port P1 continuously. Now what happens is that once I've saved my program, it has changed the colors. The comments, they have become green. The header file has become yellowish, and your data has again become blue, and the for loop and void main void, they have become another blue color. So that means that it's very user friendly. Keel is very user friendly. Suppose आप यहाँ पे हमने इसको सेव कर दिया अपने प्रोग्राम को. द नेक्स्ट स्टेप इज यू हैव टू इंक्लूड योर प्रोग्राम इन द टारगेट. सो व्हाट यू डू इज यू गो टू टारगेट. टारगेट को अगर आप क्लिक करेंगे तो वहां पे आपका एक वो खोलेगा फोल्डर सोर्स ग्रुप 1. सो इन द सोर्स ग्रुप 1 सिंपली right click source group 1 and say add new item to group source group 1. So when you do this, sorry, you will say add existing फाइल्स टू ग्रुप सोर्स ग्रुप 1. ठीक है. सो जब आप ये करेंगे तो ऑटोमेटिकली जो आपने फोल्डर बनाया था एलईडी, उसमें आपने जो led.c फाइल है वो आ जाएगी. ठीक है. सो आई सिंपली सिलेक्ट दिस led.c and say add, then I close this. So as you can see in the left side project window, your led.c has been added to the source group 1. Next step is we have to see whether we have written our program right or not. So for that, I simply go to this, the first icon you can see here, and I will say translate. And in the output window, it is showing 0 error. That means my program was without any syntax error. Unless you have 0 error, you will not be able to make hex file. Suppose हम यहाँ पे कुछ mistake कर देते, हमने P1 की जगह P1, ये तो छोटा प्रोग्राम है तो पता चल जाता, बहुत बड़े प्रोग्राम्स हैं वहां पे आपसे मिस्टेक हो गया, आपने P1 की जगह पे P लिख दिया गलती से, एंड व्हेन यू रन इट, या फिर इसमें आप डाटा कुछ और दे देते हैं. इट्स नॉट शोइंग एनी एरर. ठीक है, हमारा 0 एरर आ गया. नेक्स्ट स्टेप इज टू ब्रेक द हेक्स फाइल. सो अगेन गो टू प्रोजेक्ट, ऑप्शंस, options for target 1. This kind of window will open. In this you have a third, आपके पास जो ऑप्शन है इसमें है आउटपुट. So go to output. आपके जो हेक्स फाइल है आप उसको, इसने बाय डिफॉल्ट सेम जो आपने सी फाइल दिया था सेम नाम इसने एलईडी रख दिया. आप इसको चेंज भी कर सकते हैं, led1 आप नाम देना चाहे, बिकॉज यू विल हैव टू फाइंड योर हेक्स फाइल लेटर ऑन. अपने जो आपने बनाया तो हमने लेट से led1 दे दिया. एंड फिलहाल क्रिएट हेक्स फाइल जो है ये अनचेक्ड है. सो सिंपली चेक इट and then say okay. Okay, so once we do this, again translate, and the second one, build target. So in the output window it is showing creating hex file, 0 errors. That means my hex file has been successfully created. So these were the various steps. Now we can see our hex file also. The desktop, I had made one folder led. So this led1.hex, this is the first time it is opening, so it will ask how to open. So I'll open it with Notepad. So this is the hex file, as you can see. So compiler has made the thing so simple for you. You just have to write your program in C. You don't have to bother about this 03000. सोचो अगर आपको ऐसे प्रोग्राम लिखना होता तो कितना डिफिकल्ट था ट्रबल शूट करना भी और लिखना भी. But this is a file ultimately which you will burn into your controller. So that is the importance of your Keel compiler. Okay, so I'll just repeat once more. एक बार सारे स्टेप्स में फिर से रिपीट कर देती हूँ. So the first step will be go to project, new microvision project, make one folder. Write the name of the project you want to make, save. Next step it will ask you which particular microcontroller you want to use. Atmel, let's say. वो आपको अपने देखना है आप कौन सा यूज कर रहे हो. 8089C51, okay. Yes. So a project has been a target has been created in the target window or the project window. Next step is to write your program. So either go to file new or you can use this icon also. So here I write my program. Let's say the first program which I had written to send values 00 to FF to port 0. I write my program here. So once I've written my program, next step is to save it. Same folder it will say. Let's say I give it a name data, but here it is important to give the extension. So my program is in C, so data.c. Save. After I save it, the colors have also changed here. Next step is to go to target, source group, right click source group and say add existing files. So it's already showing you data.c, add, close. So you see when you are writing your program in assembly language ना तो आप थोड़ा कंफ्यूज हो जाएंगे यहाँ पे कि अरे हमारे तो वो फाइल ही नहीं दिख रही बिकॉज जब ये ऐड करते हैं तो वो बाय डिफॉल्ट उसको सी दिखा रहा होता है नीचे तो आप वहाँ पे अगर चेंज करेंगे .asm करेंगे तो वो asm फाइल भी दिखाएगा आपको तो हमने यहाँ पे ऐड कर दिया तो वी कैन चेक ऑल्सो सोर्स ग्रुप 1 में data.c has been added. So next step is to check if our program is right or not. So we say translate and in the out. हाँ वो जब हमने स्टार्ट किया था ना बिल्ड टारगेट किया था तो उसने बोला था कि डू यू वांट टू ऐड तो आप यस या नो करोगे उसका इतना फर्क नहीं पड़ता. यहाँ पे वो 0 एरर्स दिखा रहा है तो दैट मीन्स अवर प्रोग्राम इज राइट ओनली देन वी विल बी एबल टू क्रिएट द हेक्स फाइल. देन वी गो टू प्रोजेक्ट ऑप्शंस for target, output window, create hex file, okay. Again build target. So you can see in the output window 0 errors, creating hex file, that means your hex file has been created. You can go to your folder. So this is where you can see your hex file. Clear? This was all for today. So in today's lecture, we have seen C language programming, various programs we have seen, and then I also told you the idea of Keel compiler, how to create hex file from the C file, C program using the Keel compiler. So if you have any doubt, you can ask me. First center. RTU quota, any doubts? क्या बोल रहे हो? Any questions, sir?
फाइल साइड करने के बाद में बोलो
Sir, ma'am, we want to explain it one more time.
One more time. Okay.
Yes.
Okay. The Keel compiler, na? So go to the icon Keel Microvision 5. This type of IDE will open. Go to project, new Microvision project, create a new folder. Give it a name, whatever project name you want to give. Then it will, when you will save it, it will ask you select the device. When you select the device, let's say Atmel, any one device, then OK. It will ask you copy startup. So if you say yes, it doesn't matter you say yes or no. But after this, you will see that in the project window, one target has been created. Next step is to write your program. Go to file or this new, write your program here. The next step is to save your program. Again, it will ask the same destination. Here, important thing is that you have to give it an extension. For example, ASM or C. ASM is for assembly language. So I give it an extension .c. Then save. Next step is to add this to the source group. So right click, add existing files, add, close. So you can check also if it has been added. Go to source group. You will see that your file has been added here. Next step is to see whether your program which you have written is syntax error free or not. For that we say translate. In the build output you will say see 0 errors. That means there is no error. Next step is to create a hex file. Go to project, options, options for target, and in this the third option is output. Name of the executable file you can change also, or you can keep it the same as of your C file also. Initially this will be unchecked, just check it, create hex file and then OK. Again translate and build target. So in the output window you will see creating hex file. That means your hex file has been created. So you can check also. Go to desktop. So your hex file has been created. Is it clear, sir? Any doubts? Okay, thank you. Next. And any questions from your side?
No question? Anyone? No, ma'am.
Okay, thank you. Next center, please.
Panipat Institute of Technology, Samalkha. Any question from your side?
Panipat Institute.
No, ma'am.
Okay, thank you. Next center.
Madurai. Anna University Regional Center, Madurai.
Yes, sir. Any doubts from your side? Anna University Regional Center, Madurai. Any doubts? Yes, sir. No doubt. Next center. Surendra Institute.
Hello, ma'am.
Okay, thank you. Anyone from here? No doubts? Okay, so now we break for the tea break. And at 11:30, we will again reassemble here for the second lecture that is on real world interfacing by Dr. Baban Kumar. Right? Thank you so much.
Excuse me.
Which one? सुरेंद्र इंस्टीट्यूट. हाँ जी बताइए मैम.
मैम अगर हम डिवाइस को चेंज करते हैं तो क्या ये हेक्स कोड अकॉर्डिंगली चेंज होगा हर बार?
किसको चेंज करते हैं?
अगर हम डिवाइस जैसे कि आपने डिवाइसेस चूज किया
हाँ
तो
चेंज होगा.
अच्छा, तो उसके लिए हमें तो कुछ नहीं करना पड़ेगा, ये ऑटोमेटिकली होगा ना?
अपने आप होगा।
ओके।
Hello, am I audible? Any of the center can reply?
Welcome back to this second session on real world interfacing of 8051. We have with us our expert, Dr. Baban Kumar. He's a principal scientist in Central Scientific Instruments Organization, Chandigarh. Dr. Baban, he has done his PhD from Harvard University and postdoctoral fellowship from USA. He has vast experience and rich experience of around 16 to 20 years in the field of embedded Dr. Bhavan has guided various theses as well as he has been the project coordinator of various prestigious projects of CSIU. Today he will be taking a lecture on real-world interfacing of 8051, mainly discussing Proteus software. I hope you received I had sent yesterday the Google Drive link to all the local coordinators. I hope you have installed Proteus software in your PCs. Sir, over to you.
Thank you, madam, for introducing me. Good morning, friends, all sitting across at remote end and also at the local place. And today's lecture is on the real world interfacing with the 8051 microcontroller. And so we'll see different aspects, different contents under this lecture. And so, of course, before we start actual real world interfacing, wherein we'll be seeing input devices like microcontroller,
Hello, sir. You are not audible, sir.
मैडम म्यूट म्यूट हो रहा है म्यूट
Sir, your voice is not coming, sir.
प्लीज अनम्यूट अनम्यूट सर थोड़ा म्यूट हो रहा है मीटिंग लिखना है म्यूट हो रहा है दोबारा करो
Yeah, am I audible to all? Yeah, should I? Okay. So we were discussing about what is microcontroller, how it differs from microprocessor, and once we get familiarized with the, which I understand that it's already there, that the earlier lectures, the course has been started from yesterday or so, and they must have covered your basics like architecture and language as well. So just to have some quick interaction, what do you think? What is microcontroller and how it differs from the microprocessor? Anyone? Okay. Mhm. On a single chip. Okay, so well, for any system, microprocessor is a brain to any system. Okay, And this microprocessor actually is responsible for automating all the operations. And the same design engineer and same team actually invented the microcontroller as well. And of course, there were some shortcomings with the microprocessor. What microprocessor consists of is actually program counter, ALU, and some working registers, status words. So it only processes, okay? So it will only process. And then of course, to make it a, because now you can see my slides. I hope the slides are visible to you. So if not, are these slides also visible to the audience? Okay. So as you know, then there were shortcomings with the microprocessor. What are the shortcomings? Like memory nahi hai usme, hai na? Its own interrupts are not there. Yes, because see, to make a system a complete computer, how do we define a computer system? A computer system consists of hardware and software, right? It consists of hardware and software. That makes a computer system. And when we say hardware, hardware means basically we will have input unit, we will have output unit, we will have processor, and we will have memory. So essentially, processor is fetching the code from the memory, okay, receives the things from input also, and it processes all that. There is a program stored in the memory, and it processes and finally displays the output on the output unit. So essentially, to make a complete computer system, which is normally desired in the real world, because when you interact with the real world, you are actually interfacing with the real world and performing some job, some functionality. So you need to have a complete system, computer system in place to handle the job, to perform the particular functionality. So obviously in microprocessor, the things which were lacking include the memory, okay, wherein, because memory is must, wherein actually you are storing the program. That is the, where do we store our program? Read only memory. That is the code memory. And then, you know, the processor is fetching the program from the read only memory, that is program memory. And while performing the operations, it needs some temporary memory also. We call it scratch pad or working registers or working memory. That is a RAM, random access memory, wherein we read and write, we do both. So in memory, we need the memory. So, and after that, for interfacing with the real world, what do you need? You need the ports. So these ports were also lacking in the microprocessor. So these were basically the shortcomings of the microprocessor. There was no memory, there is no ports, okay, and there is no communication interfaces also, okay. So what happened when we put all these blocks along with my processor, it makes a complete system. And now since this all system is on a single chip, integrated chip, very large scale integration, so this is called as microcomputer on a chip. This is how we differentiate. Okay. Now, okay, so this all has been must be covered in 1980s. Manufacturer came, Intel introduced 8051, and many subsequently many further, you know, manufacturers, they introduced different derivatives, derivative controllers. The whole group is named 8051, or you can say MCS 51 standard, and they're all compatible. And these features you must be aware of, I guess, because 8051 is 8-bit, and there are instruction sets. 8051 is a RISC architecture or CISC architecture? Architecture, whether RISC or CISC, it is a CISC architecture. Okay, 8051 Intel is a CISC architecture, and the latest PIC and advanced controllers, they use RISC, and in some cases, in fact, the hybrid RISC and CISC both. And these architectures matters because this makes the computer very powerful. In order to design, ultimately you are going to use these processors or controller for designing an embedded systems. So whether it is RISC based or CISC based, Princeton or Van Neumann or Harvard architecture, this makes a computer system powerful or your embedded system powerful. Okay. So 8051 is a CISC architecture. It uses 111 instruction sets. Okay, mnemonics and your instruction sets, your assembly language instruction set, because to program you need, because there is hardware and there is software. Okay, so I'm taking just quick glimpses, and then we'll switch over to the actual interfacing. But the advanced controllers like PIC, okay, it uses only 35, 38 instructions, and that is why it is called as reduced instruction set computer. Not exactly meaning that the instruction sets are less, like 36, and compared to the 111, but they are simple and easy to execute. They're mostly one machine cycle instruction sets. Okay. Okay, Boolean processor, 64 program memory address space. Maximum address space we can go up to 64K because address bus is 16 bit. So 2 to the power 16 is 64K. That is the maximum memory that you can go for. Whereas on-chip memory for 8051 is, how much is on-chip memory? Huh? Yes. Yeah, you're right. Yes, it can go from 0000 to 0FFFF. That is 4K. Okay. So 8051 का memory जो है on chip available memory, read only memory, the memory which is available for storing your programs is 4 kilobytes. Okay. And but it can be extended up to 64 kilo. Okay. And of course, it will lead to some disadvantages as well if you increase your memory, because you have to sacrifice some ports, some bits. Same goes with the data memory. Okay. What is the on-chip memory available? There is something called as on-chip, and there is something that can be made available. So on-chip memory is RAM in case of 8051. How much is on-chip memory? 128 bytes. Okay. So 128 bytes RAM is actually available. And in fact, it uses the internal RAM. There is 256 bytes, but 128 bytes is for, you can say, GPR, general purpose RAM, and remaining 128 bytes are SFR, special function registers, which are already there, and its functionality has been already defined. You cannot change it. These are not, available to the user or programmer. Okay, then how many timer counters we have? 2 timers and 2 counters. Okay, and these are 16-bit wide. Okay, so we divide them TL and TH kind of thing. Okay, and how many input output lines? Because if you are interfacing any real world, let's say LCD or keypad or LED or motors, then you will be definitely taking into account that how many input output bits are available to the controller. IO lines, we call it IO lines. 32 IO lines, and these are bidirectional, and these are actually configured into 4 ports. Okay, and see, these are parallel ports. Okay, these ports, port 0, 1, 2, 3. Okay, right side we have even ports, and left side we have odd ports. So these 4 ports are parallel ports. Okay, serial port and parallel port, there are 2 types. So in parallel port, the speed is fast. Like if we interface the printer, then you need parallel ports. So all bits are sent at once only. That is how the parallel port works. And these are bidirectional, meaning that bidirectional means both ways it can receive as well as it can send out. That means input can be received as well as output can be sent out. So these are bidirectional. And of course, we define its functionality. If it is input port, we will see how it happens. Because while you program, you should be aware of the ports also. Because now we are going to see the real world interfacing. So that means we are going to interface something on the ports. Because ports are something which enables you to interact with the real world. The real world interfacing, the ports are something which will enable you to interact with the real world. And we'll see, therefore, the port functionality also, how the internal ports, they appear. I'm not sure whether we have already gone through that section, that portion. Is it covered how the port works? Ports का structure, internal architecture दिखाया गया है? Okay. 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 So there's something port, and then have you seen the hardware, how it is there inside? How the ports are there inside? What it is made up of? Like you have seen the instruction. Something. Are you aware that it is made up of latch and drivers and input buffers, etc.? Have you seen that? I'll show you quickly that diagram also, how the ports look like, the thing which actually get interface with the real world peripheral devices. Okay, so then you will get an idea when you send something, how actually travels and through what states. Okay, so so that also will cover. And then we have full duplex serial port. So what does that mean? Serial port, full duplex means there is half duplex, there is a full duplex. Full duplex means, yeah, UART is of course the serial port. universal or synchronous receiver transmitter UART. So this is called as full duplex. Okay, that means there are two lines available at a time. You can send as well as you can receive. So there is a transmitter and there is a receiver both. So there is a full duplex, there is a half duplex, there is a full duplex. Bi-direction, but at the same time you have two lines available dedicatedly for that purpose. Dedicatedly two lines. It's not singlex, it is duplex. So it is full duplex, not a half duplex. On the single, in half duplex, we on a single line we have transmit and receive. Whereas in full duplex, we have one for dedicatedly for transmitting and other for receiving. Pin number I guess 1670 is RxD and TXD. Okay, so that is a UART on chip. We call it SCI, serial communication interface. So these are all on chip peripherals. So there is a processor and these are on chip peripherals, which includes your serial communication interface as well. We call it on chip peripherals. Okay. And of course, yeah, you need oscillator to make the things work and synchronize. It is like a heartbeat to the whole thing. 4 kilobytes on chip program memory we have already seen. This is factory mass programmable ROM. This programmable ROM, you know, different types of ROM are there. One time programmable and only PROM, OTP, and different types are there. Okay, 128 bytes internal data memory hai. Oscillator frequency, yeah, this is also very interesting thing because your 8051 can go from minimum 3 megahertz to 24 or in fact 33 megahertz also, some versions. This is very important to know because sometimes if you are designing some embedded system wherein your requirement is that you need to have very fast performance, you need to have speed because you are sensing something in real time. आपने एक drone बनाया, in that drone you are fitting something which is based on 8 bit, it is okay 8 bit, but if it is 8051 then it can go up to only 33 megahertz. There can be some question, let's say in examination also, that how much maximum frequency, oscillation frequency 8051 can support. So it can go up to 33 megahertz. It can start from 0 also, but SRAM logic, because built on SRAM, so it goes from 3 megahertz. Dynamic can't operate below certain clock rate, but static device, okay. And for 12 megahertz, of course, it takes 1 to 4 microseconds, depending upon the mnemonics and your instructions. One machine cycle or 2 machine cycle or 4 machine cycles even. Okay, and assuming 1 microsecond instructions are most frequent, it can be viewed as an engine delivering CMOS version will less powerful. I think these are all known to you. We'll note take some important thing that all the registers in 8051 are 8 bit actually. Okay, and what are these important registers? Exactly, very nice. So these are the working registers mainly, which are available to the programmer user. And as I said, these are general purpose GPRs. Your SFRs are not available to you for programming, but these are linked with the peripherals. You have, let's say, timer, you have counter, you are having serial ports. So you need TCON, SCON, TMOD, all these. So those are actually SFRs, which the functionality of which you cannot change. So those are SFRs. So other registers are basically, as you said correctly, A, B, R0 to R7, and then we have different banks also. There are different banks, you know. The RAM in the architecture, what we have is actually processor, okay. Then we have memory, RAM and ROM, and we have ports. So what all the architecture consists of, comprises of processor, memories, and your ports. These are only the things, okay. Of course, oscillator is there and interrupt this thing controller is there. So आपका जो memory है, so memory में अगर if you talk about the ROM में तो चलो storage हो गया आपका, program store हो गया, because RAM you should be aware of because that is something which you will be using. तो RAM में कौन से registers होते हैं? There are 4 banks. 32 bytes जो है starting from 00 to 1F are basically banks. There are 4 banks. So each bank consists of 8 bytes. 8 for the 32 bytes. So आपके 32 bytes are consumed by 4 banks. ठीक है, बैंक 0 टू बैंक 3, ठीक है. और उसके बाद का जो एरिया है 20 to 2F, another 16 bytes. Have you seen that? जो होता है उसका रैम का देखा है, 00 to 1F 4 banks, and 20 to 2F ये जो 16 byte है क्या है? That is bit addressable area. So programming में आपको ये भी यूज करना है. So you need to be little bit aware of this architecture. Otherwise, in C language, if you write program, ज़्यादा जरूरत pertinent चीजों की केयर कर, बट इट बी नोन टू यू, प्रोग्रामर शुड बी नोइंग. जैसे फॉर एग्जांपल स्टैक पॉइंटर का बैंक 1 एसपी स्टैक पॉइंटर 07 होता है स्टार्टिंग एड्रेस. सो वो कहाँ से शुरू होता है, अदरवाइज कंफ्लिक्ट होता है प्रोग्राम में क्रिएट. ओके, सो वी हैव बैंक्स, 4 बैंक्स फ्रॉम 00 to 1F, 20 to 2F 16 बाइट्स आपके बिट एड्रेसेबल. उसके बाद क्या है, देन 30 to 7F, that is your scratch pad, working register, working area, scratch pad. So that area is useful. Okay, और फिर बाद में 80 to FF, ये जो एरिया है आपका, तो ये 32, 16 and 80 बाइट्स, 128 बाइट्स आपके जनरल पर्पस रैम की रैम है. एंड देन रिमेनिंग 128 बाइट जो है 80 to FF, वो आपका SFR एरिया जिसमें पोर्ट 0 सब कुछ आ जाता है. So that is what the whole architecture consists of, covers. और एक्यूमुलेटर रजिस्टर भी ये कहाँ बैठे हुए, प्रोग्राम स्टेटस वर्ड, ये भी रैम के अंदर ही है, रैम के अंदर. चलो ठीक है. सो ऑन चिप पेरिफेरल्स, कौन से ऑन चिप पेरिफेरल्स 8051 के ऊपर है? पोर्ट्स, ठीक है, सीरियल कम्युनिकेशन इंटरफेस, these are two mainly things. Then you have timer counters and interrupts. So there are 4 peripheral interface, input output peripheral interfaces available on chip. बाकी आप अभी जब हम जो रियल वर्ल्ड इंटरफेसिंग देख रहे हैं, these are external. जो ऑन चिप है वो टाइमर्स काउंटर्स है, SCI है, इंटरप्ट है और आपका पोर्ट्स है. Okay. So that's what all about the architecture. Now we will go to this memory architecture. Now you must have already seen. I am not going into much details. There are 4 basically spaces. मेमोरी के अंदर 4 spaces होते हैं. This is the complete diagram. This may not be very clearly visible, but as I explained, the region is like that. Data आपके banks हो गए, फिर वो bit addressable हो गया, फिर scratch pad हो गया. Okay, and then remaining is your SFR. That is the RAM architecture. ठीक है, memory structure जो है RAM का. Pin definitions आपको you must be, because before we start actual interfacing, you should be aware कि pin का functionality क्या है and how can we use it. तो जैसे पोर्ट 0 आप देख रहे हैं, पोर्ट 0 इज डिफरेंट फ्रॉम पोर्ट 1, पोर्ट 2 एंड पोर्ट 3. इन सबसे वेरी करेगा. एंड यू मस्ट बी अवेयर दैट पोर्ट 1, like except port 1, almost other ports, almost every port is having the dual functionality. Okay, port 1 is not having dual functionality, whereas port उसके बाद में आपने देखा पोर्ट 3 जो है लेफ्ट साइड में जो दिख रहा है आपको, so उसमें okay, visible to all of you. So in port 3 you can see that serial port pin number 1011 RxD. So in is received and that is why the arrow is going inside and transmit is going out, so it is transmitted out. Then आपका interrupts है and then timer 0, timer 1, read bar and write bar. ये जो read and write strobes जो है, these are only used in case of the external memory accesses. जब आप एक्सटर्नल मेमोरी के साथ इंटरफेसिंग करेंगे, बिकॉज यू विल फील दैट लेट्स से योर मेमोरी ऑन चिप मेमोरी इज नॉट अवेलेबल इनफ, देन यू विल गो फॉर द एक्सटर्नल मेमोरी इंटरफेसिंग. तब ये 2 लाइन आपकी अगेन सैक्रिफाइस हो जाएगी. सो बिसाइड्स दिस ड्यूअल फंक्शनैलिटी, पोर्ट 3 इज आल्सो यूज्ड एज अ IO पोर्ट्स, इनपुट पोर्ट एंड आउटपुट पोर्ट. एज अ जनरल पर्पस GPIO यूज होता है ये. एंड देन 18, 19 पे क्रिस्टल है एंड 20s ऑल दैट. Now there is very something special and unique about port 0 and port 2. Besides being used as a general purpose input output bits, bidirectional of course, they have another responsibility in cases of external memory accesses. अगर आपको RAM और ROM additionally add on करना है, besides 4 kilobytes आपने 64 के या 32 के इनकी चिप्स आती है. For example आपको 32 kilobytes का ROM add करना है, so there is a chip called as 62256. Okay, but in fact these days nobody is using this 8051 as such with a less memory. People are going for the derived controllers having a on chip memory available, lot of memory available, a lot of advancements like PIC, Arduino, ये सब कुछ आ गए हैं. So people are, but still this remains a very popular microcontroller in the industry, and people, those who are learner, they like to start with the 8051. That is why you'll find it the part of most of the syllabus in most of the universities across the world, in fact. Okay. So port 0 का क्या है? It has got a multiplex address and data lines. Okay. And therefore you will see that whenever we are writing, the arrow shows there. Whenever we are writing something on, we can write only in case of RAM, right? RAM will do read and write both operations. So writing का आप देखोगे arrow जो है ये जा रहा है और ये D0 to D7 के ऊपर. That means you can write through this data bus. At that time, through this data bus, the writing operation happens on the RAM. Similarly, in case of RAM, again we are seeing कि read operation भी RAM के केस में हो सकता है, right? So read operation will again happen through data bus. So read operation भी इसके through होगा. Okay, so it is again connected to D0 to D7. Okay. Now while performing this read and write operations, what happens? In case of ROM, only read is applicable, write is not applicable. So while we perform read or write operation from these data buses, the lower order address bus will give the lower order address byte A0 to A7. यहाँ से आएगा, है ना? That is again from port 0. And at that time, you know well the address जो address हम दे रहे हैं वो that is 16-bit byte. ठीक है? So जो higher order address byte है that is coming from the port 2. ठीक है? So this is how it works. And obviously these lines, are you aware of the function of these lines? PS, EN, ALE and EA. Okay, fully aware? Okay. Okay. So what happens? Program store enable. Okay. When we connect this ROM, okay, if it is external, the ROM is there, externally connected ROM. So you will see that PSEN signal is going out. It is pointing outward. Okay. So basically this is the signal generated by the microcontroller to enable the program stored in the ROM. So it enables the program which is stored in the ROM. Okay. And based on, and this address latch enable again gives the signal. So it synchronizes the timing diagram of that fetching the code from the ROM and all that. So so this both the signals are pointing outward from the controller and they are connected to the ROM. Okay. तो ROM में जो external ROM में आपका enable pulse एक पिन होगा तो ALE वहाँ connected होगा और PSEN भी वहाँ पर enable करेगा. So ये वहाँ से program fetch करने के लिए use होता है. And in that case जो EA है external access ये क्या होगा if it is a external ROM case? This cannot be left. This cannot be left unconnected. This is the pin. ALE PSN can be left unconnected, but EA cannot be left unconnected. ये कहीं ना कहीं connect होगा. So in case of external ROM, ये आपको because this pin meaning external access. ठीक है? So external access और बार है तो ये grounded होगा तो क्या होगा? हाई होगा तो इंटरनल होगा. हाँ, तो लो करेंगे तो क्या होगा? एक्सटर्नल होगा कि इंटरनल होगा? I leave this question to you. ठीक है. Anyways, so pin definition and functions. Capability to interface memory has impact on pin availability. आपको पता ही है port 0 वगैरह port 0 forms low order byte ये हमने डिस्कस कर लिया. General purpose port, no other special function. Port 2 general purpose or emit high order address byte. ठीक है, this we have already seen now. So parallel port, serial port, interrupt system, timer counter needs pin to interact with the environment. So ये pin का पूरा definitions था. ये इसके port 3 के बारे में है. This already is known to you. Port 3 के बारे में किसी को जानना तो नहीं है? Is known to you. Dual functionality है. Okay. And obviously at one time only one functionality is used. ठीक है. Okay. और reset is different than microprocessor है ना. इस reset में क्या difference है कि 8051 का reset जो होता है active high होता है. माइक्रोप्रोसेसर में एक्टिव लो देते हैं. उस पे reset होता है. So that is different. And pull high for 2 machine cycles. 2 machine cycle के लिए ये high होना चाहिए. Then only it will get perfect reset. And on reset, all registers are cleared except SFR. Another exception is okay. Micro jumps to this and executes the first instruction. That is known to you all. I think it originates from the 00. Actually, we have this subject in our diploma also. So just the introductory. So I have given little more basics so that our diploma students understand. Okay, using external memory, low address byte must be stored. Micro output really. So I think now better we shift to interfacing. That was little bit basics about the 8051 architecture. And now let us take quick glimpses about the ports. As I was telling you, I'll just show you how the internal ports they look like. So parallel ports, okay. These parallel ports, as you can see, they're simple, but these are efficient channels. These are very efficient channels to link microcontroller with the off-chip peripherals. The peripherals which are not available on chip, those are off-chip peripherals. For example, your LCD. We will see one of the interfacing, that is the LCD interfacing or LED interfacing. So for connecting to these external off-chip peripherals, these microcontroller, these parallel ports are very. That was okay. Okay. So anyway, these are very efficient channels for connecting with the external world of chip peripherals. As I said, these are bidirectional. Output circuitry is latched. Okay, because we have to latch the data. Either we have to latch the input data or we have to latch the output data. So we need the latch essentially. So one D-type latch is used inside. So that I will show how the circuit looks like. And always whenever we talk of ports, the question is that how to program port as an input port or as an output port, because the ports have only two functionalities. Either it will receive the data or it will output the data, send the data out. So how to do that?
By default, ports are output ports. And to make them input, we need to make always one. So when you should be
I think we can check on this, because on reset all port goes high. Am I right? On reset, we'll talk on that later. I'm saying on reset what happens when there is a, let's say, auto reset or on chip reset. Okay, so power on reset, whatever, either maybe it is button you have switch to reset or it is a power on reset. On power on also it gets reset. Okay, always. So on reset all port pin goes high, because that is in fact one of the tests that we conduct. If you have hardware with you and if you are starting to do some interfacing, not what you do is, this is one of the basic tests. We call it reset test. We call it reset test. And what we do in reset test is we either give manual reset or we power on, so it gets a reset. And what we do, we would like to see is whether all the ports have gone high, whether all the ports are high. We use the CRO or multimeter and we check that whether the ports are high or not. So you will see that all ports, they go high, except port 0, because these are multiplex data and address lines. And depending upon if you have connected the pull-up registers or not, if there are pull-up registers, they will also go high. So on reset, all the port pins go high. Okay, now we come to the input and output. Okay, so now you know well, if to make your pin input act as an input pin, then what do? You write 1 on that pin. Okay, when you write 1, it acts as an input port. And why so? That reason we will see. By writing 1, what exactly happens and why should we write 1? And then what is the condition required for acting it as an input port? What should it behave like? That we'll see in the port functionality. So एक तो input port वो act होगा, ठीक है? And for output of port, of course, we write 0. So, and then we of course are interested in how big is the driving capability of the microcontroller port pin, because microcontrollers are, see there, that is how also it differs from microprocessor. Microprocessors were only meant for processing. Microcontrollers are meant for controlling the peripherals, controlling. So there is a controller, okay? There is a word added to it, controller. And this control can happen only when there are ports available, okay? So for controlling, so therefore microcontrollers, if let's say you are driving some motor or LED, so they will control LED or they will drive the motor. They will control the LED or they will control the motor. But these microcontrollers are not meant to drive them. Drive in the sense, for driving you need to have driving power, you need some driver also, okay, because you have to have some because there, let's say there is a motor or there is LED. For example, LED takes 10 milliampere or 20 milliampere, but microcontroller pins, they cannot supply that much amount of current because they are not a drivers, they are controllers, so they can control. So drivers are something else. So driver ICs, they supply sourcing or sinking current required for the peripheral devices. So therefore, another question that we are normally interested in knowing in case of microcontrollers is how much is the driving capability. This is very essential to know, because if you don't use driver and try to drive some peripheral, you may end up in damaging your port pin. आपका पोर्ट पिन खराब हो जाएगा. एंड ये ऐसे होता है बहुत बार. आप देखोगे कि आपका एक कुछ चीज चल रहा है और आपने कुछ गड़बड़ कर दिया पोर्ट पिन के साथ में, फिर वो पोर्ट पिन काम कर, आपका वो डिवाइस और जो फंक्शनैलिटी आप करना चाह रहे थे वो हो नहीं रही है. पहले हो रही थी, अब नहीं हो रही है. सो मेनी टाइम्स इट हैपेंस कि आपके पूरे 32 इनपुट आउटपुट पोर्ट पिन्स है, तो उनमें से 2-4 नहीं चल रही है क्योंकि आपने कुछ गड़बड़ किया था, इट स्टॉप्ड वर्किंग. बाकी चल रही है. ऐसे नहीं कि पूरा कंट्रोलर ही खराब हो जाता है. सो उसकी सिंकिंग सोर्सिंग की एक लिमिटेशंस होती है, 10 मिली एम्पियर, 20 मिली एम्पियर, समथिंग लाइक दैट, आइदर इंडिविजुअल और इन ए ग्रुप. सो वो अगर आप क्रॉस कर देते हो थ्रेशोल्ड, द पोर्ट बिट्स दे गेट डैमेज. सो देयरफॉर फॉर एनी आर्किटेक्चर कंट्रोलर वी essentially आर इंटरेस्टेड इन नोइंग कि माइक्रो कंट्रोलर को बिट्स को इनपुट आउटपुट कैसे एक्ट कराना है और उसकी ड्राइविंग कैपेबिलिटी क्या है. कोई भी कंट्रोलर हो, चाहे इंटेल का था या फिर वो और आर्म का हो या फिर पिक हो, माइक्रोचिप का हो, एनी कंट्रोलर, हमें ये दो चीजें, बिकॉज फाइनली आपको उस पोर्ट पिन के साथ में इंटरफेसिंग करना है किसी ना किसी ऑप्टिक पेरिफेरल का, एंड दे आर मेंट फॉर दैट ओनली. चाहे वो माइक्रोवेव ओवन कंट्रोल कर रहे हैं, वॉशिंग मशीन कंट्रोल कर रहे हैं या एलिवेटर कंट्रोल कर रहे हैं, एनीथिंग, एनी एम्बेडेड सिस्टम एप्लीकेशन यू टॉक अबाउट. सो इसलिए आपको वो कैसे, बिफोर यू राइट द प्रोग्राम यू शुड बी नोइंग कि कैसे करना है. पिक कंट्रोलर में एक ट्रिस रजिस्टर होता है, ट्रिस, TRIS, विच डज दिस जॉब, कि इनपुट का एक्ट करना है, आउटपुट एक्ट करना है. डेडिकेटेड एक रजिस्टर है वहां पे, विच इज नॉट द केस विद 8051. सो 8051 हैज 4 पैरेलल पोर्ट्स, जैसे वो, एंड दे कैन बी इंडिपेंडेंटली प्रोग्राम्ड. ऐसे नहीं कि पोर्ट पूरे के पूरे 8 बिट्स को ही आपने करना है प्रोग्राम. बिट एड्रेसेबल है वो, दर बिट एड्रेसेबल, और इसलिए आपने सी लैंग्वेज में वो देखी भी होगी, एस बिट एड्रेसेबल कर सकते हो. और पूरा का पूरा पोर्ट करने के लिए क्या है, ये भी कर सकते हो. और अगर आप पोर्ट 0 लिखते हो, लेकिन हम क्या करते हैं, प्रोग्राम लिखते हो सी में, वी ट्राई टू डू राइट ए प्रोग्राम इन ए मैनर दैट इट शुड बी बेटर रीडेबिलिटी, उसकी रीडेबिलिटी अच्छी हो रीड करने में. दैट इज द एडवांटेज ऑफ सी लैंग्वेज ना. वी राइट द प्रोग्राम और कमेंट्स दे सकते हैं और रीडेबिलिटी अच्छी होती है समझने में. व्हेन somebody else reads our program, he understands the program fast. तो इसलिए हम पोर्ट 0 के ऊपर हमने LCD अगर लगाया है, तो हम क्या करते हैं, LCD देते हैं, LCD दैट पोर्ट. और वो कैसे करते हैं, है ना, उसके लिए भी एक कमांड होती है ना. आप डायरेक्ट LCD के ऊपर भेज दोगे तो फिर, अब LCD आपको अगर 8 बिट लगाना है, तो आप 8 पूरा पोर्ट 1 का लेट से 8 बिट असाइन करना है, तो उसके लिए होती है SFR. जैसे आप S बिट के लिए करते हो ना, ऐसे SFR होता है. ठीक है, ओके. तो ऑलराइट, इंडिपेंडेंटली प्रोग्राम कर सकते हैं. ईच बोर्ड, अब नाउ विल कम टू द पोर्ट स्ट्रक्चर. ईच पोर्ट पिन कंसिस्ट ऑफ latches. So there is a latch. Each port pin consists of latch, input buffer, and output driver circuitry. So there is input buffer and output driver circuitry for each pin, and there is a latch for each pin. Latch to hold the data, input and output circuitry to take care of the driving and all that. ठीक है। इनपुट, अब कोई भी पोर्ट हो, दो ही चीजें हो सकती है, या तो इनपुट एक्ट कर सकता है या आउटपुट एक्ट कर सकता है। तो इनपुट के लिए क्या, पोर्ट बिट लैच मस्ट बी सेट। इनपुट के लिए पोर्ट बिट का जो लैच है हमें सेट करना पड़ेगा। और आउटपुट ड्राइवर ट्रांजिस्टर, अब ये कैसे होता है, आगे आगे क्या होता है, सेट वन करने से क्या होगा, ट्रांजिस्टर ऑफ हो जाता है। ये दिखाएंगे अब हम एक्चुअल फिगर में कैसे होता है। एंड ड्यूरिंग रीसेट क्या होता है, ऑल वंस आर रिटर्न ऑन ऑल पोर्ट लैचेस। इनपुट के वक्त हम क्या करते हैं, पोर्ट बिट लैचेस मस्ट बी सेट। एज वी वर सेइंग कि इनपुट एक्ट करना है तो क्या करना है कि हमें वन लिखना है। तो हम वन जो लिखते हैं ना, तो लैच जो है वन सेट हो जाता है। और जब लैच के अंदर वन जाता है, दैट विल बी वेरी क्लियर व्हेन आई विल शो यू द फिगर। लैच के ऊपर वन जाता है तो लैच का आउटपुट क्या है, एक ट्रांजिस्टर सर्किटरी है वहां पर, जो कि इनपुट बफर या आउटपुट ड्राइवर एक्ट करती है। वो ट्रांजिस्टर ऑफ हो जाता है। हाँ, तो क्या होता है, ट्रांजिस्टर जब ऑफ हो जाता है, इट एक्ट्स एज ए हाई इनपुट इंपीडेंस। डिफरेंट स्टेट्स होते हैं ना, हाई इनपुट इंपीडेंस, ट्राई स्टेट बफर एंड ऑल दैट। सो आपको क्या है, व्हेन समथिंग इज कमिंग इनसाइड, इनपुट एक्ट करना है, तो यू वांट नो सिग्नल शुड बी ड्रॉप्ड। सिग्नल ड्रॉप नहीं होना चाहिए, जैसे ऑप एम्प का कैरेक्टरिस्टिक्स है हाई इनपुट इंपीडेंस। दैट इज व्हाई जो सिग्नल आया वो ड्रॉप नहीं होगा, है ना, ऑल द सिग्नल गेट्स एम्पलीफाइड। तो दैट इज द कैरेक्टरिस्टिक्स दैट यू आर लुकिंग फॉर। तो वो इससे होता है। सो इनपुट सिग्नल आके वो ड्रॉप नहीं होगा, प्रॉपर आना चाहिए। तो इनपुट हाई इनपुट इंपीडेंस उसको ऑफर होना चाहिए, तो होगा। सो दैट इज रिक्वायरमेंट इन केस ऑफ इनपुट। और आउटपुट में क्या रिक्वायरमेंट होती है कि आपको सोर्सिंग या सिंकिंग ड्राइव होना चाहिए। वो दैट पिन शुड एक्ट लाइक ए सोर्स और सिंक। उसके लिए वो कैसा काम करता है वो भी हम देखेंगे। ठीक है। सो ड्यूरिंग दिस, अब अभी आगे की बात बताइए कि रिसेट में क्या होता है। जैसे पहले मैंने बताया था कि वन बाय डिफॉल्ट रिसेट टेस्ट में सभी पोर्ट पे वन लैचेस पे लिखा जाता है। तो क्या हो रहा है, इसका मतलब क्या है कि इनपुट लाइंस दे एक्ट एज ए, ऑल आईओ लाइंस दे एक्ट एज ए इनपुट लाइंस बाय डिफॉल्ट। बाय डिफॉल्ट ये होता है। ठीक है। और एक्सटर्नल मेमोरी ऑपरेशंस होते हैं। अगर आपके एक्सटर्नल मेमोरी ऑपरेशंस है, जैसे रैम और रोम, ठीक है, तो उस वक्त सीपीयू क्या करता है, राइट या रीड ऑपरेशन दो ही हो सकते हैं। तो सीपीयू एफएफएफ लिख देता है टू पोर्ट जीरो रजिस्टर ऑटोमेटिकली। उस केस में रीड होता है। और रीड इन केस ऑफ किस में हो सकता है, रोम में भी हो सकता है या रैम में भी हो सकता है। रैम में रीड और राइट दोनों होता है, और रोम में रीड हो सकता है। तो उस वक्त सीपीयू अपने आप में वो एफएफ लिख देगा, दे देगा बस के ऊपर, सो दैट ऑल पोर्ट पिन्स दे एक्ट एज ए इनपुट। ठीक है। ओके, अब से, हाँ, इन केस ऑफ एक्सटर्नल मेमोरी, एग्जैक्टली दैट अप्लाइज ओनली टू द एक्सटर्नल मेमोरी। एक्सटर्नल मेमोरी ऑपरेशन के वक्त ये चीज होता है। ठीक है। बाकी ऑपरेशन के लिए तो यूजर खुद लिखता है कि पोर्ट को ऐसा करो, इनपुट या आउटपुट एक्ट करना। एक्सटर्नल मेमोरी के वक्त ऑटोमेटिकली वो सीपीयू खुद ही लिख देगा। अब दूसरा ऑपरेशन क्या हो सकता है पोर्ट के साथ में, आउटपुट ऑपरेशन। बिकॉज दिस इज व्हाट ओनली गोइंग टू हैपन व्हेन वी सी द इनपुट डिवाइसेस इंटरफेसिंग और आउटपुट डिवाइस इंटरफेसिंग। जब हमें देखेंगे अब रियल वर्ल्ड इंटरफेसिंग, तो यही दो चीजें होने वाली है। या तो इनपुट एक्ट होगा, फॉर एग्जाम्पल हम देखेंगे कीबोर्ड इंटरफेसिंग, उसमें इनपुट एक्ट हो रहा है पोर्ट्स, उस पर क्या लिखना होता है। और जब हम देखेंगे एलसीडी इंटरफेसिंग, तो वो आउटपुट डिवाइस हो गया, तो हमें लिखना है, आउट करना है। तो आउटपुट के वक्त क्या होना चाहिए, तो एज आउटपुट्स कैसे एक्ट करते हैं। तो ये सिंपल फंडा है इसके लिए। पीएन ट्रांजिस्टर अंदर दिस ऑल डिवाइसेस आईसीज आर मेड अप ऑफ वेरी लार्ज स्केल इंटीग्रेशन। तो इसके अंदर आए तो सीमॉस है तो एनपीएन ट्रांजिस्टर, पीएनपी ट्रांजिस्टर यूज होंगे। और ट्रांजिस्टर टीटीएल लॉजिक तो आजकल कम यूज होते हैं बिकॉज दे आर पावर कंज्यूमिंग। सो वो ट्रांजिस्टर यूज होंगे। सो पी टाइप ऑफ होता है जब हम उसको 1 देते हैं, है ना। पी टाइप अगर मॉसफेट है, ये थोड़े बेसिक है इलेक्ट्रॉनिक्स के। सो एंड पी टाइप को अगर आप 0 दोगे तो ऑन हो जाएगा मॉसफेट जो है। और एन टाइप के केस में क्या होता है, उसको 1 दोगे तो ऑन हो जाएगा और 0 दोगे तो ऑफ हो जाएगा। तो अब नीचे हम देखेंगे स्टेट्स फॉर पी एंड एन ट्रांजिस्टर्स। तो एक सर्किट दिया हुआ है, यही सर्किट उसके अंदर होता है, पोर्ट के अंदर। तो लेट्स से इनपुट आपने 5 वोल्ट दिया, हाई दे दिया, आपने राइट 1 किया, क्योंकि आपको इनपुट एक्ट कराना है। ठीक है। तो क्या होगा, ऊपर वाला ट्रांजिस्टर ऑफ हो जाता है, नीचे वाला ऑन हो जाता है, और एज अ रिजल्ट यहाँ पर क्या पहुंच रहा है, 0। ठीक है। और दूसरे केस में अगर आपने इनपुट 0 वोल्ट दिया, दैट मीन्स लॉजिक लो देने से वहां पर वो जो पी टाइप जो ट्रांजिस्टर है वो ऑन हो गया और नीचे वाला जो है वो ऑफ हो गया। अब आई थिंक इट विल बी वेरी क्लियर फ्रॉम हियर। वो तो बेसिक था। फॉर एग्जाम्पल अब हमने बस के ऊपर, आप नीचे का ये देखो ध्यान में, ये जो टेबल है, एक्शन हमने लेट्स से इनपुट एक्शन करना है, ठीक है। ये जैसे आपको अंदर माइक्रोकंट्रोलर के अंदर क्या सर्किट होती है उसकी जानकारी दी जा रही है, अदरवाइज यू डोंट हैव टू अंडरस्टैंड दिस काइंड ऑफ रॉकेट साइंस, बिकॉज प्रोग्रामिंग में बस, लेकिन आपको एक, भाई आप जब जीरो करते हो, वन करते हो, होता क्या है वो समझ में आने के लिए मैं इंटरनल सर्किट बता रहा हूँ। दिस इज अबाउट द पोर्ट्स दैट वी आर लर्निंग अबाउट द पोर्ट। फॉर एग्जाम्पल अभी पोर्ट जीरो के बारे में हम लर्न कर रहे हैं, ठीक है। तो और इसमें ये भी आपको रीजन पता चल जाएगा कि ओपन ड्रेन है तो पुलअप्स क्यों लगाने हैं। ये वाई वाला पार्ट थोड़ा सा अंदर का इनसाइट है इसमें। अब let us see, so this, as I said, any port is made up of latches and input output is buffers and drivers. So this acts as a input buffer and driver as well, ठीक है, दोनों एक्ट करता है, ठीक है, एज ए इनपुट बफर बिकॉज आपको हाई इनपुट इम्पीडेंस देना है, सो दिस डी टाइप लाइक। लेट्स अब इनपुट एक्शन में आपने जीरो लिखा, सॉरी कंट्रोल, चलो ये कंट्रोल ऑफ पिन ये जीरो है, आपने लैच के ऊपर एफ लिखा, ठीक है, तो मतलब बस पे ऊपर हाई आ गया आपका, एफ लिख दिया आपने, तो इनपुट डेटा क्या है, तो द पिन विल एक्ट एज व्हाट, जब वन लिखा तो क्या हुआ, देखो यहाँ वन आया डी, ठीक है, ऑन ऑन क्लॉक पल्स ये डी आया, वन आया, तो यहाँ पर क्या आएगा, वन आएगा और यहाँ पर जीरो आएगा, तो क्यू बार जीरो हो गया, और ये जीरो अब आपका जो कंट्रोल है तो जीरो है, जीरो के केस में नीचे वाला स्विच क्लोज होता है, ठीक है, तो ये जीरो यहाँ पर आ गया और जीरो यहाँ आ गया, तो ये ट्रांजिस्टर ऑफ हो गया। अब ये ट्रांजिस्टर अगर ऑफ है तो यहाँ पर स्टेट क्या हो गया, ये ट्रांजिस्टर ऑफ है, ये फ्लोटिंग हो गया और यहाँ पर हाई इनपुट इंपीडेंस स्टेट आ गया, ठीक है। सो देयरफॉर नाउ दिस पिन इज रेडी टू बी एक्टिंग एज ए हाई इनपुट इंपीडेंस, ठीक है। और यहाँ पर क्या है, वन एफ लिखा था ना आपने, इनपुट एक्शन, ठीक है, ठीक है, एक्शन क्या करना था आपने, इनपुट एक्शन करना है ना, हो गया, हाँ, ठीक है। और मेमोरी के केस में क्या होगा, मेमोरीज के केस में सीपीयू, जैसे मैंने बताया था, सीपीयू विल ऑटोमेटिकली राइट एफ, वो एफ लिखेगा इसके ऊपर, बस के ऊपर, और क्या होगा फिर, ये एज ए इनपुट पिन एक्ट होगी D0 to D7। आउटपुट के केस में तो एड्रेस भेजना होता है, इनपुट के केस में D0 to D7 डेटा रिसीव करना होता है। सो आउटपुट के केस में इसलिए नीचे देखोगे आप कि A0 to A7 आउटपुट करता है वो, और रैम के केस में राइट भी करता है, इसलिए D0 to D7 भी दिया हुआ है नीचे, है ना, नीचे वाले केस में D0 to D7 भी दिया हुआ है। ओके, तो एक इनपुट एक्शन और दूसरा एक्शन क्या हमें करना है, पोर्ट के ऊपर आउटपुट राइट करना है। सो व्हाट इज एक्सपेक्टेड, अगर हमने पोर्ट पे जीरो लिखा तो जीरो ही पहुंचना चाहिए, अगर बस के ऊपर जीरो लिखा तो जीरो ही पहुंचना चाहिए आउटपुट पे, और वन लिखा तो वन ही पहुंचना चाहिए। लेट्स सी इट हैपेंस। तो मैंने अभी आउटपुट डेटा दो चीजें हैं, मैं वन आउटपुट करना चाह रहा हूँ, लॉजिक हाई आउटपुट करना है मुझे, ठीक है, बिकॉज मैंने कुछ उसके ऊपर एलईडी लगाया है, कुछ ड्राइविंग कर रहा हूँ, एक्शन में भी एनीथिंग, एलईडी को चलाना है, ट्रांजिस्टर को चलाना है, या बजर को चलाना है, ठीक है, तो मैंने, या फिर एलसीडी की कोई पिन लगाई हुई है, समथिंग लाइक दैट, तो मैंने आउटपुट अगर वन किया, ठीक है, यहाँ पर वन किया तो यहाँ क्या हुआ, ये जीरो आ गया, ये ऑफ हो गया, ठीक है, और ये देखो ये हाई यहाँ पर आ गया, क्योंकि दिस ट्रांजिस्टर इज ऑफ, तो यहाँ पर क्या आ गया, ये ऑफ है तो 5 वोल्ट ही आएगा ना, और अगर ऑन होता तो यहाँ से करंट फ्लो होके ये ग्राउंड होके यहाँ पर जीरो आता। सो राइट नाउ इट इज कमिंग, व्हाट इज कमिंग ओवर हियर इज हाई, तो आपने आउटपुट क्या किया, हाई आ गया, आउटपुट वन आ गया। अब क्या है, पुलअप्स रिक्वायर्ड। अब ये ट्रांजिस्टर ऑफ होने की वजह से क्या है कि अगर यहाँ पर मेरे पास हाई है और मैंने अगर यहाँ पर कोई एलईडी लगा दिया है और कुछ चीज लगा दी, तो उससे क्या होगा कि, बिकॉज आउटपुट के केस में देखो, योर पोर्ट पिन विल एक्ट एज ए सोर्स और सिंक, दो चीजें एक्ट हो सकती है, ठीक है। तो अगर मैं आउटपुट वन कर रहा हूं तो इन दिस केस इट इज एक्टिंग एज ए सोर्स। सोर्स का मतलब क्या है कि अब वो सोर्स करेगा करंट, सोर्स करेगा ना, पावर सोर्स करेगा, तो वो माइक्रो कंट्रोलर की पावर ले लेगा ना। अदरवाइज अगर आपने यहाँ पुल अप रजिस्टर नहीं लगाया तो वो क्या करेगा, माइक्रो कंट्रोलर की अंदर से पावर ड्रेन करना शुरू कर देगा, सोर्स करना शुरू करेगा, तो माइक्रो कंट्रोलर आपका डैमेज हो जाएगा, क्योंकि सोर्सिंग उसकी पावर कम होती है। सो इसीलिए वो कह रहे हैं यहाँ पर ऑफ होगा, आपका ट्रांजिस्टर ऑफ होगा सोर्सिंग के वक्त, और ट्रांजिस्टर ऑफ है इसलिए पुल अप रिक्वायर्ड है। ठीक है, क्योंकि ट्रांजिस्टर ऑफ है तो आप +5 वोल्ट आ गया और ड्राइव करेगा, एज अ सोर्स एक्ट करेगा। दूसरा केस है आपका जीरो। जीरो के केस में क्या है, जब जीरो लिखा तो यहाँ पर क्या हुआ, ये 1 आ गया, 1 आ गया तो ये ऑन हो गया, ये ऑन हो गया ना ट्रांजिस्टर। अब ट्रांजिस्टर ऑन हो गया तो ये यहाँ से करंट फ्लो होना शुरू हो गया, तो यहाँ पर जीरो आ गया ये जंक्शन के ऊपर। तो दैट मीन्स आपने जीरो लिखा था, जीरो यहाँ पर आ गया, और जीरो आने का मतलब क्या है, सिंक करेगा। जीरो मीन सिंकिंग। तो सिंकिंग के केस में आपको कोई खतरा नहीं है जी, गेटिंग माय पॉइंट। सिंकिंग के केस में यू डोंट हैव एनी खतरा, सो इसलिए पुलअप्स आर नॉट रिक्वायर्ड, पुलअप्स आर नॉट रिक्वायर्ड, इसलिए पुलअप लिखा नहीं है यहाँ पे। ओके, और जीरो बोला था, जीरो पहुंच गया। बट आपको सोर्सिंग के वक्त खतरा है, इसलिए आपको पोर्ट जीरो के ऊपर, अब आप ये बता के नहीं चलोगे कि पोर्ट जीरो ने सोर्स एक्ट करना है कि सिंक एक्ट करना है, वो तो डिपेंडिंग ऑन एप्लीकेशन कुछ ना कुछ होते ही रहेगा, या तो सोर्स हो गया सिंक होता रहेगा। इसलिए द प्रैक्टिस इज वी कनेक्ट पुल अप रेजिस्टर्स, वी ड्राइव इट हाई। अब पुल अप रेजिस्टर लगाने से क्या होता है कि वो जो करंट है वो कहाँ से आएगा, पुल अप रेजिस्टर हम कहाँ कनेक्ट करते हैं, सोर्स को कनेक्ट करते हैं ना, एक एंड पुल अप का एक एंड हम कहाँ करते हैं कनेक्ट, पुल अप पोर्ट जीरो पे अगर पुल अप रेजिस्टर लगाया वीसीसी पे लगाते हैं, और वो वीसीसी कहाँ से आता है, सोर्स से आता है, वो कंट्रोलर से नहीं आता। सो इसके जो भी करंट उसे ड्राइव करना है वो सोर्स से आएगा, कंट्रोलर से कुछ लेना देना। कंट्रोलर सिर्फ क्या कर रहा है, एक्शन कर रहा है, कंट्रोलर ये वाला एक्शन कर रहा है, ऑन ऑफ वाला एक्शन। सो यू गॉट द फंक्शनलिटी। सो दिस इज हाउ इट वर्क्स, दिस इज अबाउट पोर्ट जीरो, एंड सेम गोज विथ ऑल अदर पोर्ट्स एज वेल। जितने भी बाकी भी पोर्ट्स हैं वो सब ऐसे ही काम करते हैं। जैसे आगे के पोर्ट, पोर्ट ये कौन सा है, हाँ ये पोर्ट 1, ये भी ऐसे ही काम करेगा। यहाँ पर जो भी लिखोगे वही टेबल फॉलो करना है, कि यहाँ 0 लिखा तो यहाँ 1 आ गया, तो ये ऑन हो गया, और ये 0 हो गया। तो इस तरह से सेम इट वर्क सेम वे, सेम सभी पोर्ट्स ऐसे ही काम करते हैं, सभी के अंदर ऐसी फंक्शनलिटी दी हुई है। बस उसमें इसमें आप देखोगे कि हर एक के अंदर पुल अप रेजिस्टर्स लगाए हुए हैं, सभी पोर्ट्स में पुल अप रेजिस्टर्स है, उसमें नहीं था। ठीक है, अब वो ड्राइविंग भी आप लिटिल बिट ड्राइविंग कर सकते हो, ये बाकी के पोर्ट्स पे भी आप ड्राइवर एज ए ड्राइवर पोर्ट को लिमिटेड 10 मिली एम्पियर 20 मिली एम्पियर तक कर सकते हो, उससे ज्यादा नहीं। फिर तो ड्राइवर लगाना पड़ेगा कुछ, तो वो अभी हम देखेंगे, एक लेट से एप्लीकेशन देखते हैं हम। नाउ विल सी सम बेसिक इंटरफेसिंग। तो अब हमने बेसिक हमारा वो देख लिया, लेट्स सी सम इंटरफेसिंग एग्जांपल। फॉर एग्जांपल, सो आई होप यू हैव अंडरस्टूड। ओके, now let's see some simple output devices, है ना। और simplest output devices क्या है, LED। most simplest to begin with is LED। and LED का सबको सबको पता है, LED में 2 टर्मिनल होते हैं, एनोड एंड कैथोड। ओके, ठीक है, इट्स लाइक अ डायोड, बट लाइट इमिटिंग डायोड है। एंड सिंस इट इज लाइट इमिटिंग डायोड, उसमें क्या है कि सो सिंस इट इज लाइट इमिटिंग डायोड, तो एनोड और कैथोड होगा। और एनोड को, और आपको इंटरफेसिंग में, नाउ वी हैव स्टार्टेड द रियल वर्ल्ड इंटरफेसिंग, टॉकिंग अबाउट द रियल वर्ल्ड इंटरफेसिंग। किसी भी इंटरफेसिंग में सबसे पहले आपको जानना जरूरी है कि हार्डवेयर कौन सा इंटरफेस करना है, और उस हार्डवेयर के बारे में आप जान लोगे तो आपका सिंपल इनपुट आउटपुट इंटरफेसिंग है। फॉर एग्जांपल, नाउ वी आर टॉकिंग अबाउट द एलईडी, सो फर्स्टली यू नीड टू हैव knowledge about that peripheral input output device, for example in this case LED। सो एलईडी का जैसे हमारे बेसिक हमें नॉलेज था कि ओके एलईडी में 2 टर्मिनल होते हैं, एनोड और कैथोड, और एनोड को हमें पॉजिटिव देना पड़ेगा, कैथोड को नेगेटिव देना पड़ेगा, वो फॉरवर्ड बायस में होगा, वो एलईडी ब्लिंक करेगा। So these are the basics to be known about any input output peripheral devices that you want to interface। So चाहे वो same goes with the LCD or printer or any input output peripheral devices। The very first thing you need to do is actually knowing about the details about that particular input output peripheral device। So as we have seen now कि इसमें LED के केस में input और output होगा। We'll see in this different types of, let's say, okay, so output devices में there are different numbers like 7 segment है, LCD है, we'll try to cover most of them। तो LED के केस में we know now the basics that anode को पॉजिटिव जाना चाहिए, कैथोड को नेगेटिव जाना चाहिए, तो एलईडी ब्लिंक करेगा. एंड वी ऑल्सो नो द वोल्टेज ड्रॉप अक्रॉस एलईडी इज, कितना वोल्टेज ड्रॉप होता है? 1.4 volt, 1.6 volt to 2 volt, depending upon manufacturer also and how it is made of. And then how much is the current that it needs? Maximum current it drives is 10 to 20 milliampere current उसको चाहिए LED को intensity के लिए. And of course that we can vary with the current limiting resistor. तो अब ये सब बेसिक्स इंफॉर्मेशन हमें जो है ओम्स लॉ की इंफॉर्मेशन ये सब इतनी एक्सपेक्टेड है. तो अगर हमें एलईडी, अगर हम डायरेक्टली लेट से ये विदाउट करंट लिमिटिंग रेजिस्टर कनेक्ट कर देते हैं एलईडी को, तो क्या होगा? I इज इक्वल टू वी बाय आर, है ना. तो वी आपका एलईडी को आपने एक एंड पे लेट से एलईडी को कनेक्ट करके रखा है वीसीसी, ठीक है. यू आर यूजिंग पोर्ट पिन एज ए. अब मैंने अगर एलईडी को वीसीसी लगा दिया और कैथोड को मैंने पोर्ट पिन पे लगा दिया, तो मैं पोर्ट पिन को एज अ क्या यूज कर रहा हूँ? एज अ सोर्स कर रहा हूँ कि सिंक कर रहा हूँ? यस. तो दिस इज वेरी इंपॉर्टेंट टू नो. बस ये हमें मतलब अंधा बन के ये नहीं कि भाई वो एलईडी को ये लगा दिया होगा, तो ऐड क्या हो रहा है, करंट कहाँ से कहाँ फ्लो हो रहा है, वी शुड नो. सोर्स से करंट आके ड्रेन में जाएगा, दैट मींस सिंकिंग हो रहा है, इधर सिंक हो रहा है, सोर्स वीसीसी से आ रहा है. ओके. सो वहां से वीसीसी लगा दिया हमने एनोड को, और कैथोड को हम जो है पोर्ट पिन पे लगा देंगे. एंड अब कुछ जैसे मैं बात कर रहा था कि डायरेक्ट अगर लगा देंगे विदाउट एनी करंट लिमिटिंग रेजिस्टर, तो I इज इक्वल टू वी बाय आर होगा. और वी कौन सा है? ये +5, नॉर्मली +5 देते हैं हम डिटेल लॉजिक में. 5 डिवाइडेड बाय रेजिस्टर, तो वो डायोड का बहुत कम होगा. डायोड रेजिस्टेंस will be very very, and if we ideally equate it to 0, which is not a practical case, but क्या होगा फिर? I is equal to V by R. So you see कितना infinite, ideally infinite हो रहा है. So it means very 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 high amount of current is going to flow. And as I said, every port pin has got a limitation threshold level in terms of sourcing and sinking. Now you see कितना बड़ा सिंक हो रहा है, and so it will damage. तो आपको आपकी जर्नी जो है बिफोर यू स्टार्ट इट एंड्स. आप जैसे माइक्रो कंट्रोलर के साथ में कोई रियल वर्ल्ड इंटरफेसिंग की जर्नी शुरू कर रहे हो, बिफोर यू स्टार्ट एक्चुअली इट एंड्स. एंड यू नो वेल बिगन इज हाफ डन. सो यू हैव टू स्टार्ट नाइसली. सो इसीलिए आपको पहले कैलकुलेशन करनी चाहिए कि चलो 1.6 वोल्ट इतना उसके अक्रॉस वोल्टेज ड्रॉप होता है, एंड 20 मिली एम्पियर अगर मुझे करंट देना है, तो मैं अकॉर्डिंगली R इज इक्वल टू V बाय कैलकुलेट कर लूंगा. मैंने 10 मिली एम्पियर कर लिया, ऊपर मेरा 5 वोल्ट है, और 5 वोल्ट माइनस दैट ड्रॉप 1.6 समथिंग. तो अगर मैं 3000 मिली वोल्ट कर दूं लेट से ऊपर, डिवाइडेड बाय योर 10 मिली एम्पियर लेट से मुझे फ्लो कराना है, तो 10 कितना है फिर? अराउंड 300 ओम्स आ जाता है. ठीक है. सो आर अगर मैं 300 ओम्स, बट नाउ यू विल सी यहाँ पर 330 ओम दिख रहा है. पीपीटी में आपको दिख रहा है कितना है? यू सी दैट देयर इज 330 ओम दैट आई हैव कनेक्टेड. व्हाई सो? कैलकुलेशन में मेरा निकला 300 ओम, और पीपीटी में मैंने लिखा है 330 ओम. हाँ हाँ, यस. क्या है कि हमने थेरोटिकली कुछ किया कैलकुलेशन, बट एक्चुअली प्रैक्टिकल वर्ल्ड में मैन्युफैक्चरर से लोकल मार्केट से आपको उतना अवेलेबल भी तो होना चाहिए. सो जो मोस्ट वाइडली एंड लोकली इजीली अवेलेबल स्टैंडर्ड रेजिस्टेंसेस है वो 330 ओम इस टाइप के होते हैं. तो इसलिए 330 ओम में, बट स्टिल इट इज वेरी नियर, इट स्टिल सर्व्स द पर्पस. ओके. एंड यहाँ पर एक जो है CMOS इन्वर्टर भी लगाया गया है टू बी ऑन सेफर साइड. दिस CMOS इन्वर्टर इज एक्टिंग एज ए नाउ ड्राइवर. दिस इज एक्टिंग एज अ ड्राइवर. इट एज अ ड्राइवर भी काम कर रहा है. ठीक है. तो इसलिए अब मुझे इस एलईडी को ऑन करने के लिए मैं लॉजिक 1 लिखूंगा पोर्ट के ऊपर, और इट गेट्स कन्वर्टेड इनटू 0, एंड देन वहां पर से करंट फ्लो करके इट वर्क्स. So these are the basics. LED can illuminate if forward bias and enough current is flown through it. Current required range from few to 10 milliampere. Voltage drop range from 1.6 to 2 volts. Needs driver to supply 10 milliampere current. Driver चाहिए होगा. क्योंकि एक एलईडी तो चलो चला भी लोगे आप, इतना तो होता है कंट्रोलर का, लेकिन मल्टीपल अगर लगाओगे तो डैमेज हो जाएगा. And needs driver to this. R is used to current limiting resistor. 3 volt is drop across R. ठीक है. इसमें से कुछ समझ में नहीं आया तो पूछ लेना. ओके. एंड टू लिमिट 10 मिली एम्पियर हमने इतने का वो रजिस्टर लगा दिया. स्टैंडर्ड रजिस्टर इतने की वैल्यू आती है. चलो ये रेड ग्रीन है तो एक्सरसाइज है कि यू कैन कनेक्ट मल्टीपल एलईडीज आल्सो, रेड ग्रीन एंड येलो, जैसे हमारा ट्रैफिक लाइट का होता है. सो यू कैन राइट सम प्रोग्राम, सिंपल प्रोग्राम की ग्रीन येलो रेड 3 हमने एलईडी लगा दिए, और ये इस तरह से इसका अरेंजमेंट हमारा हमने लगा दिया. सो यू गो ऑन राइटिंग 1 to all port bits one after other with some delays, and it will go it will illuminate one after other. फॉर एग्जाम्पल इस प्रोग्राम में आप देखो, अब हमने क्या किया कि 0 मूव P1 में 04 दे दिया ना, तो हमारा यहाँ पर क्या था, कौन सा ऑन हो जाएगा, ग्रीन किस पे है, 1.2 पे है ना, तो 4 जो है 4 आ गया ना, 1.2 इज 1 अगर हम करेंगे तो 4 हो जाएगा, तो ये 4 लिखेंगे तो ये टर्न ऑन हो जाएगा। ठीक है, ओके, बीच में सेकंड दिया, सो दिस इज सिंपल प्रोग्राम, वी डोंट हैव टू स्पेंड टाइम ऑन दैट। सो बेसिक एलईडी का इतना सिंपल है, आप एलईडी इतने आसानी से ग्लो करा सकते हैं विद द माइक्रो कंट्रोलर, एंड द प्रोग्राम इज ऑल्सो वेरी सिंपल। आप सी में भी लिख सकते हैं, पोर्ट जो भी पोर्ट यूज करोगे उसके ऊपर 1 0 ही करना है विद सम डिले। अनदर इंटरेस्टिंग इंटरफेसिंग इज 7 सेगमेंट्स। ठीक है, 7 सेगमेंट्स क्या है, यू नो 7 सेगमेंट्स ABCDEFG, उसमें 7 सेगमेंट्स होते हैं, एंड ऑल these segments are made out of LEDs only. Each segment consists of one LED. 7 segment में almost 70 milliampere का करंट वो लेता है। Okay, and these 7 segments are mostly used for displaying your binary coded digits, BCD digits जो है, ठीक है, 0 to 9 जो है इस तरह से, and so this is how it looks like, 7 segments ABCD, इस तरह से हमारा अरेंजमेंट होता है। और इसके दो टाइप के कॉन्फ़िगरेशंस होंगे, कॉमन कैथोड और कॉमन एनोड। कॉमन एनोड में जो है पूरे एनोड पार्ट जो है कनेक्टेड होंगे टू ए कॉमन पॉइंट, एंड कॉमन कैथोड में ऑल कैथोड पॉइंट्स आर कनेक्टेड टू ए कॉमन पॉइंट, and the other remaining ends are named, they form segments A B C D up to G. Okay, और okay, so these are some basics, as I said, अगर कोई भी इंटरफेसिंग हमें करनी है तो सबसे पहले हमें उसके बेसिक जानने हैं, और वो ये है कि 7 सेगमेंट क्या है, कि कंसिस्ट ऑफ 7 सेगमेंट्स, 7 LEDs ABCDEFG, इट कम्स इन कॉमन कैथोड और कॉमन एनोड कॉन्फ़िगरेशन। और इसमें क्या है, आपने एक्चुअल 7 सेगमेंट देखा होगा, तो उसमें मल्टीमीटर से हाउ डू यू नो कॉमन पॉइंट्स, मल्टीमीटर से आप 2 पॉइंट को कनेक्ट करेंगे, नीचे 5 पॉइंट होंगे, ऊपर पॉइंट, जैसे ABCDEFG कितने हो गए, 7 हो गए ना, 7 हो गए, तो उसमें आपको, और एक कॉमन हो गया 8, तो उसमें आपको 8 या 9 या 10 आते हैं उसमें, है ना, उसमें तो 2 लाइन जो है ना कॉमन शॉर्टेड मिलेगी आपको, अगर आप प्रैक्टिकल 7 सेगमेंट देखोगे तो शॉर्ट मिलेगी, दैट इज द कॉमन पॉइंट, दैट इज हाउ वी कैन रिकॉग्नाइज वाइल वी वर्क प्रैक्टिकली, उस तरह से हम उसको जान सकते हैं। और भी है कि आप मल्टीमीटर से वो ग्लो भी हो जाते हैं, है ना, इफ यू कनेक्ट मल्टीमीटर्स तो आपको सेगमेंट्स भी पता चलती जाएगी। So okay, it comes in different configurations. Current required to light segment is similar to LED. वही current 10-20 milliampere चाहिए इसको, mainly used to display BCD digits. One port is enough for one 7 segment. एक 7 segment हम एक port से कर सकते हैं. We'll see the diagram. And microcontroller cannot supply the required amount of current, क्योंकि एक segment में 10 milliampere चाहिए होगा, 7 segment में 70 milliampere चाहिए होगा, तो we'll use some buffer IC. 74LS244 is a buffer that can be used. तो बफर आईसी क्या करेगा, तो रिक्वायर्ड अमाउंट ऑफ करंट, क्योंकि हम सिंकिंग में यूज करेंगे इसको, तो सिंक करा देगा उतना करंट। एंड आउटपुट हाई वोल्टेज 74, चलो ये तो 244 की डिटेल्स है कि इसकी आउटपुट हाई वोल्टेज 3 वोल्ट की जाती है, इसलिए हमें 100 ओम का रेजिस्टर हम कनेक्ट करेंगे। ये माइक्रो कंट्रोलर की ड्राइविंग सिंकिंग सोर्सिंग कैपेबिलिटी दिखाई है, टोटल करंट कितना दे सकता है वो 15 मिली एम्पियर, एक्टिव मोड में आपको देखो 15 मिली एम्पियर या 20 मैक्सिमम जा सकता है। Okay, so this is how we connect. Let's say port 1 पे हमने कनेक्ट किया, है ना, so 74LS244 ये आईसी के थ्रू इनपुट जाएगा, और आउटपुट जो है थ्रू करंट लिमिटिंग रेजिस्टर, जैसे हमने एलईडी कनेक्ट किया था वही हिसाब है कि पहले, बट दिस इज अ सिंगल पैकेज, सिंगल एक पैकेज है, DIP ड्यूल इन पैकेज आता है, उसके थ्रू इनपुट जाएगा, और आउटपुट जो है वो थ्रू करंट लिमिटिंग रेजिस्टर हो जाएगा 7 सेगमेंट्स पे ABCD। So let's say I'll show you some code, मतलब अगर हमें ओके, तो जैसे कि आप, अच्छा आपको दोनों एट ए टाइम नहीं दिखेंगे, स्लाइड और ये बोर्ड नहीं दिखेगा, ओके, तो एज वी सी कि 7 सेगमेंट में मैंने बना दिया है, लेट्स से माइक्रो कंट्रोलर है MCS 51 एंड कोड लेट्स से 1.0 से शुरू कर दिए और यहाँ हमने एक बफर लगा दिया, दिस इज 74, ठीक है, LS244, दिस इज बफर IC और ये हमारे रजिस्टर्स हैं, ठीक है, कोड 1.0 and these registers will go to after register they go to 7 segment, ये हमारा 7 segment है, 7 segment मतलब 1 2 3 4 5 6 7 और इसमें हमारा ये A है, ये B है, C है, ये D है, E है, F है और G है, ठीक है। So these are the 7 segments they look like. Is it visible? Okay. तो ये हमारा करंट लिमिटिंग रजिस्टर हो गया, करंट लिमिटिंग रजिस्टर हम 100 ohms के लिए लगा दिए एंड ये पोर्ट 1.0 to 1.6। तो बीसीडी हमारे अगर हमें लेक्चर डिस्प्ले कराने बाइनरी कोडेड डेसिमल डिजिट्स लाइक दैट, तो हमें माइक्रोकंट्रोलर के ऊपर कौन सा कोड जो है भेजना पड़ेगा प्रोग्राम में, दैट इज हाउ वी विल सी हाउ व्हिच कोड शुड बी सेंट। तो आपका ये जो है 1 पॉइंट ओके नॉट ऑडिबल, इज इट ऑडिबल?
No, sir.
Okay. Chalo, we have in the slides only. I have everything available in slides, so I can put it in the slide only. So, for let's say you want to write, let's say 0, ठीक है? अगर आपको 0 लिखना है BCD के ऊपर, ओके? अगर 0 लिखना है तो कौन से सेगमेंट्स हमें ऑन करने पड़ेंगे? Exactly. Except G, all segments will have to glow. Then it will display 0. अब एक्सेप्ट जी अगर सबको ग्लो करना है तो हमें क्या देना पड़ेगा? इन ऑर्डर टू मेक एलईडी ग्लो, बोर्ड पे क्या देना है अभी? दिस इज अ कॉमन कैथोड 7 सेगमेंट, ओके। कॉमन कैथोड का मतलब है कैथोड जो है दैट विल गो टू ग्राउंड, ओके, और एनोड को हम पॉजिटिव देंगे तो ग्लो करेगा, ठीक है। सो हमें पॉजिटिव भेजना है तो हम क्या करेंगे, क्या लिखना पड़ेगा? एक्सेप्ट जी हमें सबके ऊपर 1 पोर्ट्स के ऊपर 1 लिखना पड़ेगा, ठीक है। तो सभी एलईडीज जो है वो ग्लो करेगी, ठीक है। सो व्हेन वी देयरफॉर अगर आप देखोगे कि 1.0 से लेके 1.6 तक सबके ऊपर मैं 1 कर दूं एंड 1.7 को लेट से डोंट केयर कंडीशन कर देता हूं, उसको मैं 0 मान लेता हूं। 1.7 भी है ना, एमएसबी मोस्ट सिग्निफिकेंट बिट जो है पोर्ट 1 का, एमएसबी 1.7 है, उसको मैं 0 करके रख देता हूं परमानेंट। So now you will see this is the code. मैंने यहाँ पर पोर्ट 1.7 को 0 कर दिया, BCD डिजिट मुझे 0 डिस्प्ले कराना है, ऑल 7 सेगमेंट्स मैंने 1 कर दिए, ओके, एक्सेप्ट टी, ठीक है। नाउ यू विल सी दैट क्या कोड बन गया है, मैं यहाँ पर 0 मानता हूँ, ये 1 बन गया 7 और ये बन गया E। तो 7E हेक्स, ये अगर मैं पोर्ट 1 पे लिखूंगा तो 0 जो है BCD के ऊपर डिस्प्ले हो जाएगा। So this is how we generate the codes. तो सिमिलरली एक और एग्जांपल ले लीजिए, अगर मुझे 5 डिस्प्ले कराना है तो कैसे करोगे, क्या कौन से सेगमेंट ग्लो कराने हैं? AFDCD, राइट, AFDCD, ये देखो 5 में A मैंने 1 कर दिया, F का गया, CD भी 1 हो गया और G और F, ठीक है। तो ये भी मैंने 1 कर दिए, तो ये कोड बन जाता है 5D, ठीक है। कोड कैसे बनाने आपको पता ही होगा, है ना, 4, सो 5 भी बन गया। तो दिस इज हाउ वी डिस्प्ले द बाइनरी कोडेड डिजिट्स ऑन दी 7 सेगमेंट्स। तो ये कोड हम पोर्ट के ऊपर राइट कर देंगे, और उसके ऑब्वियसली दीज आर आउटपुट डिवाइसेस, तो हम पोर्ट बिट को एज ए आउटपुट पोर्ट पिन करना है हमें, तो 1 नहीं लिखना है, 0 लिखना है, तो पोर्ट बिट्स दे विल एक्ट एज ए आउटपुट पोर्ट। जैसे पोर्ट 1 है ना, पोर्ट 1 को मैं कर दूंगा 0100, 0 लिख दिया, so now port pins, they are ready to act as a output pins, and then I'll send this code. कौन सा आप लेट्स से हम 5 कर रहे थे ना, ये 5 भी मैं सेंड करूंगा, ठीक है। मूव करो, असेंबली में आप मूव करोगे और सी में आप डायरेक्टली राइट करोगे उसके ऊपर, तो ये वहां पर डिस्प्ले हो जाएगा। ओके, इन प्रैक्टिकल वर्ल्ड क्या होता है कि वी ऑफन कम अक्रॉस कि हमें मल्टीपल बीसीडी डिजिट्स करने होते हैं, क्योंकि आप काफी जगह, कभी कभी क्लिनिक्स, हॉस्पिटल, काफी जगह वो ना टोकन नंबर्स लगे होते हैं। इवन ईटिंग जाइंट्स वगैरह है, वहां पर भी टोकन नंबर डिस्प्ले सिस्टम लगे होते हैं, इवन पहले बैंक में भी होते थे। तो दोज आर मल्टीपल बीसीडी डिजिट्स। तो मल्टीपल करने हैं तो क्या होगा, टाइम मल्टीप्लेक्सिंग टेक्निक हमें यूज करनी होती है। उसमें लेस देन 1 सेकंड के अंदर अगर आप फास्ट लिखते हो तो इट गिव्स अ इफेक्ट टू द आई कि एज इफ साइमल्टेनियसली डिस्प्ले हो रहा है। सो यू हैव टू गिव अ लेस देन 1 सेकंड डिले in between the writing, so you'll get that writing effect. So multiple में क्या है कि आपका जो है okay, multiple का मैंने फिक्स नहीं दिया है यहाँ पर, बट multiple में आपको क्या है कि जैसे ये हमने किया था सिंगल एलईडी किया था, तो इसका जो कॉमन कैथोड पॉइंट है, मल्टीपल के केस में क्या होता है, कॉमन कैथोड पॉइंट पे हम एक ट्रांजिस्टर लगाते हैं 2n, let's say 4 times 2, that is one of the transistor and transistor available, that acts as a driver। क्योंकि आप क्या है, ये 7 सेगमेंट है, 70 मिली एम्पियर इसमें से सिंक होगा, ठीक है। और आपको चारों डिजिट्स, चारों बीसीडी को कंट्रोल करना, राइट, एंड सिंस यू हैव टू कंट्रोल ऑल 4 बीसीडी, तो आपको ये जो कॉमन एनोड पिन है, ये भी आपको कंट्रोलर के एक पिन को कनेक्ट करनी होगी। सो आपके 7 सेगमेंट पे कॉमन कनेक्ट हो गए, जिसमें 7 बिट यूज हो गए, और एक बिट आप जो है हर एक बीसीडी के लिए एक सिंगल बिट और यूज करोगे टू कंट्रोल इट्स कॉमन पॉइंट एज वेल, ठीक है। इस तरह से आपको सभी कॉमन पॉइंट्स भी कंट्रोल करने हैं, और ठीक है। सो आई थिंक वी आर रनिंग शॉर्ट ऑन टाइम, एनीवेज, ओके। सो बीसीडी इस तरह से हम करेंगे, और एक मैं लिक्विड क्रिस्टल डिस्प्ले का कर लेता हूँ क्विकली, ठीक है। लिक्विड क्रिस्टल डिस्प्ले हमें पता है ऑलमोस्ट जितने भी हमारे आउटपुट डिवाइसेस है दिस डेज, पॉइंट ऑन सेल डिवाइसेस है, और एनी डिवाइसेस जिसमें आउटपुट में आप कुछ देख रहे हो, wherever you are reading, maybe your mobiles or your POS or any machines, तो जहाँ पर so LCDs are used normally, okay। So this is the most familiar output devices, and they have got advantages over LEDs as it is high contrast, एक इसका advantage है, but it requires light source in dimly lit environment। जहाँ पर जैसे रात में अगर देखना है, so it needs backlight। आपके मोबाइल में भी आप क्या करते हो, बैकलाइट ऑन करते हो, so that is what it is required, which is not the case with 7 segment। 7 segment का अपना ही शार्प होता है ना, बट एलसीडी का फिर एक डिसएडवांटेज ये है कि ये जो आपका बैकलाइट है, ये दिस टेक्स लॉट ऑफ पावर, लगभग 200-300 मिली एम्पियर पावर जो है वो सिर्फ बैकलाइट ही ले लेता है, whereas only LCD takes only 5 to 10 मिली एम्पियर। so that much is a big difference, कहाँ पर 200 मिली एम्पियर, कहाँ पर वो 5-10 मिली एम्पियर। and this is very important point because these days most of your devices are battery operated। तो जहाँ पर आपने कोई अगर एम्बेड सिस्टम एप्लीकेशन डेवलप करना है, so you have to take into account कि बैकलाइट अगर ऑन करेंगे तो इतना मिली एम्पियर करंट लेगा, तो आपकी बैटरी बहुत जल्दी ड्रेन आउट हो जाएगी, एंड दैट इज द रीजन आपका मोबाइल जो है ऑटोमेटिकली उसका बैकलाइट ऑफ करते हैं। और नाइट रीडिंग वगैरह आजकल ऑटोमेटेड हो गया कि ऑटोमेटिकली बैकलाइट कम हो जाता है। दीज आर पावर सेविंग मोड्स। ओके, बेसिक कंस्ट्रक्शन एज आई सेड कि जब भी इंटरफेसिंग करनी है आपको बेसिक से यू शुड बी फैमिलियर विद। तो इसका हार्डवेयर ऐसा है कि व्हेनेवर वी अप्लाई वोल्टेज, ठीक है, अक्रॉस द एलईडी सेगमेंट्स पे अक्रॉस में एक वोल्टेज अप्लाई किया जाता है, इट डेवलप्स सम इलेक्ट्रोस्टैटिक फील्ड इज सेटअप एंड दैट अलाइंस द क्रिस्टल इन द लिक्विड। लिक्विड क्रिस्टल टेक्नोलॉजी है ना ये, तो क्रिस्टल जो है लिक्विड के अंदर दे गेट अलाइंड बाय व्हेन वी अप्लाई द वोल्टेज, और जब वो अलाइन हो जाते हैं, व्हेन दे आर अलाइंड, अलाइनमेंट इज देयर, that allows the light to pass through the segment. उस segment के through light pass हो जाएगा और वो ये डायग्राम देखिए आप, ये liquid crystal यहाँ पर पड़ा हुआ है, यहाँ liquid crystal पड़ा हुआ है. So the crystals that are there in the liquid, they get aligned when we apply the voltage across it, and when they get aligned, तो क्या it allows the light to pass through, right? It allows light to pass through to the crystals. Then नीचे क्या है, black cardboard backing दी हुई है. In every LCDs there is a black cardboard backing. जब light is passed through, तो नीचे आपको जो black है वो आपका segment दिखता है. आपको जो दिखता है ना black, that is basically black cardboard backing जो नीचे होती है, which is because that crystals are now aligned and that it allows the light to pass through. That is how जो भी आपको digits आपने glow कराने हैं, you go on aligning those crystals, okay, and accordingly you can see those particular things. Different types के LCDs है, okay. So that was the basics about the LCD. Now there are different types of LCDs available: 2 line, 4 line, 20 character, 40 characters, है ना. Character की limit होती है ना, बड़े displays भी होते हैं, छोटे displays भी होते हैं. So these are the different, normally from Optrix is one of the manufacturers for LCDs. और अब LCD को अगर initialize हमें करना है, what we have to do is we have to send the initialization bytes, initialization commands भेजनी पड़ती है. Okay, that is the only important thing as far as the LCD goes. And this is how we do the interfacing of LCD with the microcontroller. LCD के अंदर क्या है, right side you can see this is LCD. There are 8 data lines. और ये डेटा लाइन जो है पोर्ट 1 से कनेक्ट कर देंगे, तो 8 बिट, दिस इज 8 बिट इंटरफेसिंग. एंड देन एलसीडी के ऊपर क्या है कि RS RW enable, these 3 control pins are there. Controlling any device in real world interfacing, there is always one data bus, there is a control bus, and there is an address bus. In case of LCD, no address bus is required, so there is only data bus which is connected to the port pins, and there are control lines which is connected to the port pins. And any device is always having some power requirement. तो ये power pins है यहाँ पर, VCC and VE, and this is ground. VE is to adjust the contrast of the LCD. Okay, so likewise, every interfacing there is a hardware connection in every interfacing. So in hardware wise, you make the connections like 8-bit interfacing है तो 8-bit आपने data lines of the LCD is connected to the ports and 3 control lines. आपने hardware एक बार connection कर लिए. Now what comes next? Software. You have to write the software for this particular interfacing. So LCD interfacing में सबसे पहले आप familiar हो गए LCD कैसा है, LCD के अंदर कितनी data lines है, कितनी control lines है, कितनी power pins है, वो connection आपने properly कर दिए as I have shown in the slide. You have made the connections. Now what you have to do is you have to write the commands. ठीक है, controller के अंदर आप program लिखेंगे, those commands reach to the LCD and it works. So as far as the LCD goes, there are only 4 commands which are required to make the LCD work. ठीक है, तो पहली कमांड होती है फंक्शन सेट. व्हाट इज फंक्शन सेट कमांड? फंक्शन सेट कमांड क्या है? ये सबसे लास्ट वाला कॉलम दिखा रहा है फंक्शन सेट कमांड. इट सेट्स द इंटरफेस इनटू 8-bit मोड. की इंटरफेस जो है, बिकॉज एलसीडी डजंट नो एनीथिंग, लेकिन एलसीडी के अंदर एक कंट्रोलर रखा हुआ है. सो देयर इज अ हैंड शेकिंग बिटवीन दैट कंट्रोलर व्हिच इज रिसाइडिंग इनसाइड द एलसीडी एंड द माइक्रो कंट्रोलर. सो वो हैंड चेकिंग करेंगे तो सबसे पहला कमांड जाएगा फंक्शन सेट विच टेल्स द एलसीडी दैट द इंटरफेसिंग मोड इज 8-bit एंड नंबर ऑफ डिस्प्ले लाइंस कितनी है, 2 लाइन है, 4 लाइन है, वो बता देगा. और कैरेक्टर फॉन्ट क्या रखना है, 5x7 फॉन्ट रखना है. कैरेक्टर के साइजेस होते हैं ना, फॉन्ट साइज. सो ऑल दिस गेट्स प्रोग्राम. सो एलसीडी नोज दिस इज द फंक्शन सेट कि आपका 8-bit कम्युनिकेशन है, नंबर ऑफ लाइंस कितनी है और फॉन्ट साइज क्या है. दैट इज द पर्पज ऑफ फंक्शन सेट कमांड. उसके बाद में आप जब एलसीडी के ऊपर लिखते हैं तो एक कैरेक्टर लिखने के बाद में वो ऑटोमेटिकली राइट साइड में जाता है ना. ओके, एंड मोर और लेफ्ट से आना है कि राइट से आना है कैरेक्टर, कि टॉप से आना है कि बॉटम से आना है, ये कौन, मतलब ऑटोमेटिकली तो नहीं होगा. फॉर दैट ऑल्सो यू हैव टू टेल समथिंग. सो देयर इज अ कमांड एंट्री मोड सेट. एंट्री मोड सेट कि भाई जो भी लिखा जाएगा वो लेफ्ट से आएगा, विच इज और कन्वेंशनल ओके प्रैक्टिस, कि लेफ्ट से लिखा जाएगा और राइट में वो शिफ्ट होता जाएगा. राइट, ऐसे होता है ना. सो एंट्री मोड यहाँ से सेट होता है कि भाई सेट्स द कर्सर मूव डायरेक्शन एंड स्पेसिफाइज टू शिफ्ट और नॉट टू शिफ्ट, स्पेसिफाई करता है एंट्री मोड सेट। और तीसरा है सो फंक्शन सेट 38 या 30 इसके कमांड्स होते हैं, देन एंट्री, एंड देन द थर्ड इज नॉर्मली क्लियर स्क्रीन। ओके, थर्ड इज क्लियर स्क्रीन, तो वो पूरी डिस्प्ले को क्लियर कर देता है। नॉर्मली दीज आर ओनली 3-4 कमांड्स व्हिच आर रिक्वायर्ड। हाँ, इंपॉर्टेंट कमांड इज आल्सो डिस्प्ले ऑन ऑफ कंट्रोल, कि भाई सेट्स ऑन ऑफ ऑल डिस्प्ले, डिस्प्ले को ऑन भी करना है, कर्सर को भी ऑन करना है, कर्सर भी दिखना चाहिए, और कर्सर को ब्लिंक करना है कि ब्लिंक नहीं करना है। सो डिस्प्ले ऑन ऑफ इज अनदर कंट्रोल कमांड। सो CDB, तो 4 कमांड भेजते ही LCD का इनिशियलाइजेशन हो जाएगा। ये उसका प्रोग्राम है। मैं एक प्रोटिस का क्विकली आपको एक प्रोग्राम दिखा देता हूँ, LCD कैसे ब्लिंक कर रहा है। बट दिस इज हाउ वी राइट द प्रोग्राम LCD का, जिसके अंदर आपको इनिशियलाइजेशन करना है and then LCD.
This program is Thursday class में इनको करवा दूंगी।
Yes.
LCD का।
Yeah, in Thursday's class, madam will cover your program on LCD. ठीक है, और मैं एक प्रोटियस का आपको इसका क्विकली डेमो दिखा देता हूँ कि हाउ द LCD वर्क्स इन how we interface and how it works. So LCD interfacing 8-bit. So Proteus, we have Proteus project 8-bit interfacing. Okay. So we have to just firstly ensure the hardware connection. Then we have to write the 4 commands. So पहले हम कमांड देते हैं, 4 कमांड देने के बाद में क्या होता है, LCD का ना इनिशियलाइजेशन हो जाता है। जैसे होता है ना कि जैसे हम मॉर्निंग में जैसे घर में we get ready, we do brushing and we take bath, and so we are ready to serve. So that is our initialization. So similarly LCD अपना initialization हो जाता है, and then जब initialization हो जाता है, then you can write the characters on the LCD. Like it shows, you must be seeing that when I play, simulate this program. इसके अंदर आप देखोगे माइक्रो कंट्रोलर 8051 है, and there is a basic oscillator circuit, reset circuit, and this LCD is connected in this particular case to port 2. Port 2 को 8-bit का एक LCD का इंटरफेस किया गया है. This is 8-bit interfacing, and there are 3 control lines, RS, RW, and enable. तो RS is actually select register. सिलेक्ट रजिस्टर क्या है कि वो कंट्रोलर, अब कंट्रोलर से कुछ भी भेजोगे, LCD को कैसे पता कि वो कमांड है कि डेटा है? डेटा इज लाइक इट इज डिस्प्लेइंग द कैरेक्टर, वेलकम टू CSI, इट इज डिस्प्लेइंग, सो दैट इज डेटा। और कमांड इज लाइक LCD को बोलना है कैरेक्टर तुमने लेफ्ट से राइट करने हैं, राइट से लेफ्ट करने हैं, फॉन्ट साइज क्या रखना है, कर्सर को ब्लिंक करना है नहीं ब्लिंक करना है, दैट इज कमांड टू द LCD। सो ये RS डिसाइड करता है, गवर्न करता है, एंड tells the LCD that whatever is coming on the data lines is command to you or is it a data to you. तो अगर सिलेक्ट रजिस्टर अगर हम RS 0 करते हैं, then this select register, if it is 0 set to 0, then it means it is a command to the LCD. So ये RS पिन चेक करता है LCD के अंदर भी कंट्रोलर है, LCD itself is a small embedded system. तो ये कंट्रोलर उसके साथ कम्युनिकेट करके RS राइट करेगा 0 कमांड, तो वो कमांड लेगा, और जब मैंने ये अब जो डिस्प्ले किए कैरेक्टर RS मैंने 1 किया है, तो ये डिस्प्ले हो गए कैरेक्टर। ओके, और मैं LCD के ऊपर लिखना है RW राइट कर रहा है, तो इसलिए RW को मैं ग्राउंड कर दूंगा, सो इट इज राइटिंग। सो आई होप यू हैव अंडरस्टूड द LCD प्रोग्राम।
Let us now connect to the center. Audio quota, any doubts, sir? Audio quota. Okay, sir. जी doubt, please ask.
The screen is not visible to us. The font size is very low.
मैं ये प्रोग्राम में आपको करवाऊंगी LCD का।
ओके
ये मत देखो।
Okay, this will be covered in your Thursday's class. Okay. This slide is visible to you. This one, this command slide.
Yes, sir. Yes, sir.
This one is visible, right? So these are the main commands that we sent, and madam already covered your programming, how we write the program for the 8051. And the connection that I have showed you clearly, I think this connection is also visible to you.
Yes, sir.
Hardware interfacing diagram is visible to you.
Yes, sir. Yes, sir.
It's visible. Huh? So, okay. So this is what is important here. This is what is important here, that you have to understand the hardware connection diagram. I think which is very well clearly visible to you.
The program I will be covering it first.
And the program writing is getting covered, and you need to know what instruction should be written on the LCD. So this one is the instruction diagram, instruction function 6. These are the instruction function 6. Different instructions that you write on the LCD to make it initialize. As far as the LCD interfacing goes, what we have to understand is only interface, this initialization, and which takes only 4 commands.
Next center. Madurai. University. नहीं आवाज
हेलो
ये मत दिखाओ
ये तो visible.
Sir, this diagram is not visible to us.
ऊपर से जूम कर लो इसको जो भी आपने किया था ना यहाँ से जूम कर लो
Okay. Is it getting visible now? Is it visible now?
Yes, sir. Yes, sir.
Okay. So this you can see that there is a controller, okay, that port 2, and which is connected. Lines, 8-bit lines are going to LCD pins here. Okay, this is the LCD pins here. All 8 data lines are connected here. Okay. So the same connections that I showed you on the slide, same connections. Okay. So when you connect like this, the diagram that I showed you, the controller, and you can display this kind of messages. So we are writing to the LCD. This is called as writing on the LCD. So once we initialize, then we can write. The only difference between 2 instruction set is RS is set 1 when it is writing any data on the LCD, and RS is set 0 when it is giving command to the LCD. So for writing the messages that you are seeing here, like for example, welcome to CSIO, RS will be made 1.
Any other doubts regarding the any other doubts?
No, ma'am.
Okay. Next center. Panipat Institute. IIT.
Hello.
Yes, sir.
Ma'am, what happens if I change the operating frequency of 8051?
What?
What happens if I change the operating frequency of 8051? As we know, operating frequency of approximate 12 megahertz. If frequency change, then what happens, sir?
Can you repeat?
Hello. Sir, are you audible, sir?
said you want to change the properties.
Ma'am, you are not audible.
Yeah.
Hello.
Hello.
वो ऑटोमेटिकली ऑफ हो जाती है उसको रन ऑफ हो जाता
Yes, sir. Can you please repeat the question? So please repeat the question.
Hello, not audible, ma'am.
Can you sir write as text because we are not able to hear clearly what you are trying to say. Can you write as a textual query?
यस सर, थोड़ा सिस्टम के पास आ जाइए, आप ऑडिबल हो जाएंगे हमें।
मैम वॉइस बीच में ब्रेक हो रहा है मैम।
सर आप थोड़ा सिस्टम के पास आ जाइए।
सर सिस्टम के थोड़ा सा पास आ जाइए और सिस्टम से दूर है इसलिए आपकी आवाज बहुत इको हो रही है।
यस सर।
हाँ जी। हाँ जी सर
Hello,
बोलिए।
ma'am. Ma'am, frequency of 8051 change, then what happened, ma'am? 8051 frequency.
Frequency.
It,
ये चेंज हो जाएगी ना।
Yes.
Execution.
Frequency changes, then actually we have to adjust the delays, because while we send the, if it is if your question is
This is a very
regarding,
good question. Very good question, sir. Actually, there is one concept of machine cycle. Please remind me when I take the class on Thursday. I will tell you the concept of machine cycle. Then you will know that what will change. That is an important concept with class. Okay.
receiving your voice, ma'am, but I will discuss later, ma'am.
Yeah, I'll tell you about this detail when Thursday starts. Because there is a machine cycle.
when frequency changes, crystal upon we have crystal divided by 12. That decides your machine cycle. So when you change the crystal frequency, your machine cycle changes. Okay, machine cycle, total time taken by machine cycle changes. Okay, and therefore it has some effect on your interfacing related work also. So this is to be taken care. So normally what we do when we design our hardware, the crystal is all fixed. So we have already taken into account what crystal is already connected in the system, and accordingly the programs are written now. Okay. So definitely there is a linkage between machine cycle, crystal, and accordingly the programming.
Okay, sir. Thank you, sir.
Well,
है कोई और सुनता है? Anna University Research Center Madurai. Any doubts you have?
We don't have any doubt, sir.
Okay, thank you
okay,
so much.
thank
We
you.
have some suggestion.
Yeah.
Please try to communicate in English only, because we South Indians don't know the Hindi.
Oh, okay.
From yesterday morning itself, you are casually using the Hindi words, but we can't understand anything.
But you should have told this earlier, na? You are telling this in the second day.
Except the word HINDA, Hindi, we don't know Hindi.
Yeah, I got the point. But I said you should have told this earlier, na? What were you waiting for till now? Anyways, we'll take care of that. Okay, thank you.
अच्छी से भी कैंडिडेट दे रहे सर
प्राइवेट कॉलेजों को प्राइवेट को
तो गवर्नमेंट में तो ज्यादा मिलना चाहिए ना
सब्सिडी मिलती है गवर्नमेंट सब्सिडी इसी इसीलिए तो कम हुआ है क्या सब्सिडी का मतलब है आपके चीज ना अगर आप कंपनी करोगे तो कौन सा हाँ सब्सिडी इसीलिए मतलब सब्सिडी
गवर्नमेंट को 10 रुपए कैंडिडेट मिलोगे
ये कहाँ का है हेलो हेलो वो भी आ गया ना सर उधर भी हो
ग्लोबल एजुकेशन की डेवलपमेंट संदीप सर वो दे देते, वो मैसेज डालते ग्रुप में, वो आज मैडम देखती है ना कि कोई बैठा नहीं है। अच्छा मैं डाल देता हूँ, चलो। ये आ गई मैडम। कुत्ता भी है नहीं रहा। आवाज क्यों नहीं आ रही है? आवाज नहीं आ रही ना।
Hello. Hello. स्क्रीन देखना आ रही है? शुरू करें? वेरी गुड आफ्टरनून. आ जाओ. हाँ, चंदन मम्मी आ जाओ. A very good afternoon to all. My apologies for the delay. Actually, today we are having some connectivity issues at our side, so that's why there was some delay here. We have come to the third session of today. That is on Mr. And we have with us experts, Mr. Anurag Chaudhary and Mr. Chandan. They are actually our ME students, but they have worked a lot on robotics and embedded system. And today they will be sharing their experiences with you on the various interfacing of sensors with the embedded system. They have also brought one robot with them based on Arduino, which they will be demonstrating to you. It will be, I'm sure, very interesting lecture. And please try to ask questions also from them and get as much as possible. Over to both of you.
Thank you, ma'am. Good afternoon to all the participants, teachers, and who are connected with us. So today we are going to start real-time interfacing of 8051 and Arduino-based project, and we are also make the some project Arduino-based and some interfacing, real-time interfacing of LCD and some other sensors are there. So we are starting my PPT on the. First of all, we discuss some basics about sensors. Okay, or I'm also grateful to Dr. Ritula Thakur to give me this opportunity to share some knowledge of real-time interfacing of Arduino and 8051 microcontroller. So we are going to start the real-time interfacing. Real-time interfacing. Okay, so these in my PPT also, they all are the sensors which are available. I'll show you the all sensor in the hardware part. So this one is a LDR sensor. I show the working what is the LDR. Okay, this is the LDR, and this is IR sensor are there, potentiometer and the flex sensor, and I also told the all the working and the applications. How can you make a smart robotics applications and other robotic arms applications? Okay, this is the PIR sensor, and this is the ultrasonic sensor. Okay, so this is my development kit. Okay, this is my development board. These many type of development board available in the market. This one is a one type of development board are there, and some other type AVR type board are there. This is the AVR type board, because we need some crystal and switches and some two capacitors are there to making the programming of the 8051. Okay, so this is the many type of controller available in the market. board. Okay, so and it have many in this kit. It have 4 matrix keypad also at, and the 8-bit LED are there. ISP connections for the programming of the 8051, and this one is a 8051 microcontroller. And in the, if talk about the hardware, this one is a 805 microcontroller. So it is put in the kit, and also the 7 segment display are there. And this one is a 7805 voltage regulator, because the our we need the 5-volt signal to the control the signal. Okay, and the power supply will be 9 volt or 12 volt. To converting the 5 volt, we using this voltage regulator. Okay, this is the display selector, and the many other options are there. The LCD holder, this is the LCD. We are connected LCD here, and this is the A to D converter IC, because we take the analog signal from the sensors. Some signal are digital, but most of the signal are analog. So we use in a 8051 to convert analog signal into digital signal. Okay, this is the external internal switches are there. Reset button is there, and this one is the RTC real time counter. Okay, this is the real time IC. So this is DB9 female connector to show the monitor, and connected with your some monitor also display. And these are all the output devices. Means you take the input from the sensors and controlling the motors, relay, display. You can display your data, 7 display segment. This is the relay. This is the stepper motor. And in the application for the robotics arm, we use some stepper motors to controlling the all motors in robotic arms. Okay, so first we going to discuss some sensors. So this is the sensor. First sensor is the LDR, and I also show the interfacing with the 8051 both and Arduino also. So this is the sensor LDR. It is a light dependent sensor. So when the light fall on the surface of the LDR, it change the resistance. Okay, when the resistance will change, this totally depend on the light. How many light fall on the surface, the resistance will be vary. Okay, so it is also called the photoresistor. And the next is IR based sensor. Actually, it is an object detector sensor. In the figure, this one is a photodiode. This is a simple LED. This is transmitter, and this is the receiver. Okay, when some object will be detected, he through the ray coming, and this one is a receiver. The ray will be received by the photodiode. Okay, the range is adjustable. This one is a variable, means you can measure the distance. How can you use the most distance? Okay, so you can, this is the adjustable range, and it is operating of the 5-volt DC, and the sensitive up to 30 centimeter. Okay, and it is based on the digital only. I also told the input signal are 2 types: analog signal and the digital signal. So from this sensor we take the analog signal also and the digital signal also. Okay, so these are the okay, it have a 3 pins. One is a 5-volt providing, and the second one is a ground, and third one is a digital input. Okay, so this digital input connected with the 8051 some pin P.0 means which you want, and in the Arduino also you can connect the digital point 10 to 13 pin you have there. Okay, so there are many applications in the industry for the automatic door open and the robotic applications, object detector, and there are many applications in industry also. And we are going to other sensor. This is my ultrasonic sensor. It is measure the distance to count, means how much distance are there. So ultrasonic sensor model has a 2 transducer, one for the transmit and other for the receiver. Both are fixed on the PCB. You see in the figure, this one is a transmitter and this one is a receiver. It transmits the signal and it receives the signal. How many time it take? So it calculate the distance. What is the distance between the object and the sensor? Okay, and ultrasonic sensor provide precise non-contact distance, and its range 2 centimeter to 400 centimeter also. Okay, so there I also connected with some circuits. You see later, and this is the most important sensor. It's a very useful sensor to making some robotics arms, and you also control with by this sensor from your hand to control all the appliance, electrical, and the motor also you connected. And printing for the dumb pupil, I show you that demonstration. I make a model for the dumb students. You have not clearly say to some what he want. So he using the fingers. It is a when we are tilde the sensors, it change the its resistance. Just like the LDR change the resistance when the light is fall on the LDR, so it's vary the resistance. So it's when is bending, so it's change the resistance. This one is a LDR, this one is a flex sensor, and when it tilt, this one is, suppose this is tilt, so it's vary the resistance. I show you the demonstration also. And this sensor can flexing or bending in the one direction. If we move in the other direction, it not be changed. It is a fixed. Okay, it's work only the one direction only. And these sensors are easy to use. They are basically register that change the value based on how much they fixed, and if they unflexed, the resistance is about 10k. Okay, and when we connected in the circuit, so we use the 10k resistor with this, because we are making a voltage divider circuit, and what will voltage change by the this and calculate and go to the microcontroller. And this one is a LCD. Okay, so here LCD is connected to the Arduino also and the microcontroller. I show you the how connected with the and how to program with the LCD, and some program print on the LCD also. So LCD have a 16 pin. First we discuss about LED some basics. So it have a 16 pin. So 8 pin will dedicated to the data. Means LED is used for 4-bit data and the 8-bit data also. We depend on the data, how much data we print on the LCD. So it has the 16 pin, 8 pin dedicated for the data, pin number 16, pin number 7 to 14 we dedicated to the data. First pin number first, it's a ground pin, and the second pin is supply, 5-volt supply give to the second pin VCC, and the VVE pin is voltage enable pin, it enable the LED. So we are grounding this pin. RS is a register select, read and write pin, and this is also enable pin. Okay, these pins are also contrast control of the LCD. Okay, so now these are the connections. How can connect the LCD? You can demonstrate. Okay, so I demonstrate also. I make some program to display the data. Connect with wire. Okay, you see in the video also the print Nital Chandigarh, the 1 byte data will be provided byte by byte. So one letter N I T T T, it's take some delay. So I provide in the delay program 1 second, means 1 millisecond program delay. So it's coming. This is the program you see. This is the program I make. So in the program I use as a port 0 as a data. Okay, and you can see in the connected the port 0 use as a data, and the enable pin, pin number 4 and the pin number 6 register select pin, these are connected to the port 2. You can see नीटर चेंज का थोड़ा प्रिंट दिखा. हाँ, okay, this is the Nital Chandigarh is printed. Okay, and Ritula ma'am is also told you about the how can make a hex file and how to burn. I also show you the how to make a file, because of we in this laptop we have no kill software, so that's why I'm not show you.
They've already been discussed.
Okay, so Ritula ma'am is already discussed.
Hex file version is done.
Okay.
Burning is shown also.
It is a universal burner. If your any kit are not working, you take your microcontroller and fix it in this, and you make a hex file to connect it this wire. Okay, and it use the Wheeler programmer, so it is free of cost available in the net. You can download and burn directly. Okay, it will no require any ISP cable, sub cable, Arduino cable you use, and you can Wheeler programmer. Okay, This is a universal board. You can use the 8051, 8052 and the Philips that you want. Okay. Huh. Especially universal keyboard. So we are come back to the PPT. Okay. And this is the our IR sensor. Okay, I also make the by IR sensor a robo. It's an object detector robo. And first of all, I discuss the interfacing with the 8051. After that, we are going for Arduino also. Okay, because this robo is working on the Arduino, but this interfacing is based on the 8051. Okay, when the object will detect some object, it gives the signal to the point 0.1, and it's also give to the output. I show you the program. This is the hardware connections I build, and I show the demonstration also. I make a video of this program, and this is I write the program. This is the hex file, means it's a register name which found you as the header file, and the S bit A is equal to port 0 point, means port 0 की जो आपकी 0 pin है, that's I'm using as a input, and the FF is used for the you are making the port 0 as a output. Okay, as a input. Okay, when you make a input, you show in your program as a FF. If you want to choose as a output of a port, then you use 00. Okay, this is show the hex file, and this is use 00. If you are not used program, means if you are show the port as an output, you are no need to define it. If you are not right, P1 is 00, that is it's no need, means okay. The S.
Tell them what is connected at P0.0 and what is connected at P1.0 in your hardware.
Okay.
Accordingly, you can discuss this.
Okay. S bit A port 0 means port 0 pin. It connected as a input, and B port 1 and 0 it's connected as an output pin. So
input पे IR sensor लगा है.
Okay, this sensor is connected. This is provided by the 5 volt because it needs, in the figure I show you, it needs the 5 volt for the operating voltage, and it have a ground pin. It's connected to the ground from the kit. This is the 5 volt and this is the ground connected, and the LED is connected. This is the current limiting resistor connected to the LED. I show you the demonstration.
प्रोग्राम का है.
Okay.
बेसिकली जब आपका आईआर सेंसर आएगा तो एलईडी ग्लो करेगी ना.
तो
प्रोग्राम एक्सप्लेन करते हैं पहले. See, we have discussed the C programming. So now in this case, it is interfacing with the IR sensor. The hardware is such that at at port pin P 0.0, you have the IR sensor connected, and at port pin P1.0, you have the LED connected. So our logic is that whenever the IR sensor detects some object, the LED should glow. Okay, so the first thing is that in order to make the port 0 as an input port, you have to give write 1 to it. Not necessary that you have to make the whole port high. What you can do is that you can make that particular port pin 0 itself, 1 itself. That will also make that particular bit an input bit. But anyways, in this program, what they've done is that they have made this port 0 as an input port because it is here where the IR sensor is connected, and at port 1, the LED is connected. That is an output mode. So the logic is this: while when I've already told you that this is for continuous repetition. That means you want to repeat this particular process continuously. Okay. So while one. So what we want to compare is if A is nothing but P0.0 equal to 1. You remember yesterday I told you the difference between single equal to and double equal to. If you are putting single equal to, that means you are assigning that particular value. But if you are putting double equal to, that means you are comparing the value. So here we are comparing. If port pin 0.0, that means where the IR sensor, it becomes high. That means IR sensor has detected some object. It will become high because its connections are like that. VCC will be connected to it, so it will detect a high. What action should it take? B should be 1. And what is connected at B? Your LED is connected. So that means whenever the IR sensor detects any object, your LED will glow. If does not, else B should be 0. That means LED should not glow. So that is the logic of the program. Now he will demonstrate this also.
So you can see in the video, this is LED connected to the port 1 0.0. When we are touch the some object are coming in the front of, when some object are coming in the front of the sensor, LED will be off and LED will be on. Okay, you can see in the video also. Okay, and this is the base is on the base of IR sensor. I show you this demonstration how to work it.
So they've made one robot also based on IR sensor.
Actually, we adjust the range and the light is fall on the that, so that's why it's not work. No problem. When I discuss the Arduino, that's why on that time I show you this. So this is the Arduino board. In the Arduino board, this is the USB port to burn the program in the Arduino. Okay, and this is the power port. When you use in the external circuit, such as in that circuit, so that's this port is used for providing the power. Okay, when we are programming the power from the laptop, that's why we using this cable. But in the otherwise we use this cable. This is the power port, and this pin is used for the analog read. So the sensor is coming in the analog pin also, and this is the Atmel microcontroller in the kit, and this one is a serial communications program. Okay, this is LCD connected to the Arduino also. This one is connected LCD. Okay, all about I also told you all the basic connections of LCD, and in this program we use the LCD in the pin number 13 and 11 used as a RS and enable pin, and the other as a data pin. Okay, we use the 4-bit data only, so that's why it's so, and it connected to the Arduino when we are providing the power, due to the power. So you can see all the data print on the LCD. Okay, this is the programming. I also show the working because the I want water, so that the print on the LCD. Okay.
So I want water. It is being displayed there.
Okay, because I want water, I show this lead because I use this sensor to the dumb people have want water and it's not able to say to someone I want water. Okay, making these things easy, so I use the flex sensor and how it is say ki I want water. So you can use the some speaker also, and when I need water, so he move the finger, he move this finger, and the LCD print the I want water. Okay, if he not he's happy, so no, it's right as a I am happy. And when he want food, so the next finger will be move and the data write I want food. Okay,
So this is for those disabled people who cannot speak. Just by the gestures, if suppose they move the finger forward, they may it may indicate that they need a water. So the LCD it will display I need water. Suppose he's satisfied, he'll say I'm happy. So he can wave his hand like this. That is why he showed you the flex sensor in the beginning. So the flex sensor, it is sending the signal, and the LCD, it is displaying it. So the application may be that his attendant may be at some distance, and he may read that thing, and then he may come to him. So for such kind of applications, you can develop using this.
Okay, I show you the demonstration. This is my L flux sensor, and I make a gloves. I have no gloves, so that's why I'm using this finger. Okay, I put the sensor here. This is the sensor, and I put sensor here. This sensor in the PPT, the it is connected to the when we connected to Arduino and read the value of the sensor, just like a potentiometer, just like a LDR. Okay, so it's vary the speed and it's change the resistance. So LCD prints some values. Okay, so we can use these values as an input. When suppose it's less than 200 values, so it's print the I am happy. Okay, when it state it's print the 200. Okay, after that when it's changing the resistance, the value will be changed. So it's print the I am happy means what you want to print. Okay, suppose I show you this is a cable and
only in one direction.
yeah, it's one only. I in the starting I told you it's when this side. Okay, this side is front. When you bending this side, it is not working. When you bending this side, the resistance will be vary. Okay, in the only one direction. Okay. Yeah. Means the resistance potentiometer change the resistance, LDR change the resistance, so that's same working principle are no problem. But the principle is bending. Okay, the potentiometer have no bending, LDR is depend on light, so that's why is depend on bending only.
So in this case, the LCD is connected directly to the Arduino. You may also make such an arrangement that at one end you are having the Arduino, and if the attendant is not along with the person, you may send the data wirelessly, maybe through Bluetooth, and there may be some receiver at that end. The LCD is displayed there. So many kind of things they can be done. Many applications they can be developed.
And you also control some motors. Okay, from your finger using the RF module. I show you how to make a wireless robo, and from the RF module you
in
can
such kind of applications where a person is disabled, so you can use these things with a wheelchair. So suppose he wants to move further, he just moves his finger in one direction, the wheelchair will move forward in direction. He may bend it in some other way, and it will go in the reverse direction. So it can be used in that way also. So now he's going to demonstrate the same thing, how by using this flex sensor, it will be displaying the things.
Now, please can focus on that LCD. Okay, in the screen, it is right. I am happy. Okay, when I am folding my finger, I want water. Okay, it's change the text. Okay, now it's back. It's using the okay. The working principle is basic only. You can use as a what you want in the application. You also control the speed of the DC motor from your finger. You connect it to and you vary the resistance and the speed will be controlled. Okay, firing angle will be controlled. It's depend on the application, and you make a robotic arm clone. Okay, making the using the 5 sensor. Actually, this is the costly sensor. It's 500 rupees only one. Okay, so it's bigger thing when you purchase the 5 sensor for controlling the 5 finger, and you make a robotic arm clone hand also, and they have some clone arm, and you can control the arms or the using the stepper motor also. So controlling the 5 fingers, you use the 5 stepper motor every and making some arrangement. Okay, so you can make
that's a very interesting application Anurag is discussing. What he said was that in this case he's used only one finger and one flex sensor. Suppose you want to make a clone of your hand. I'm sitting here, okay, and I want to operate something which is at some distance. So what we can do is that just by moving my 5 these thing flex sensors, I can make a glove here, and I could put those 5 flex sensors here, and my hand's clone will be there. Like whatever movement I'm making with my hand here, the same will be replicated at some distance. So what he said was that you can control stepper motor, etc. also with the same thing. Like suppose you want to control something, you want to control the movement of something. So just by the gesture here, that is one very interesting application he has
So one
discussed
time,
with
so
me.
you show again. Actually, I fix it. No problem.
So he's again demonstrating with the flex sensor.
The display show you. Okay, so it's right. I want food. Okay, and when I'm filling it, I want water. Okay, the text will be changed now. So changing the value of the resistance, we will print the some value. Okay, and what we want, and using I want to display, but only the one finger. Okay, when we are means making a some dictionary, what he want the particular cheese. Okay, so we using the other finger we can make it. Okay, and it is also the principle of this sensor is basically the voltage divider. What is the resistance will be vary, and the voltage change of the this flex sensor will be read. Okay, by the and this is also work complete. Okay, so I going to the next. This one is a figure. Okay, I show you the video. I make the this project video also. So see this video. How can it work? Now I am happier. Okay, I am happy. I want, and when I want something, so I move my finger and it write I want water. Okay, when we are fixed, so it is no problem. It is depend on your application. How can you use this sensor? Now we are going for the next sensor. Okay, in the robotic application, I show you how to make a basic robot and how to make a wireless robot also. So this is the basic block diagram of the wireless robot. It have one transmitter and the one receiver using the RF module. This is the RF module. Okay, so using the RF module, you can make any system wireless. It is use only 4-bit data. 4-bit data will be controlled, means you control the two motors also. The direction of the motor you can control easily, and speed of the motor you can easily control. Okay, this one is the receiver module. The encoder IC12HTD. I show you the component also, and some push button to controlling the direction. It's forward, reverse, left, and right also. And this one is the receiver circuit, and it is ST12ED decoder circuit, and the motor driver L293, and two DC motors are used in my project. And these all the components are required to making a wireless robot. And using this sensor, we also make the smart robot using the flex sensor, using the LDR, IR sensor, object detector. Okay, so we are making this sensor and make a smart robot also. So two DC motor are required, and the IC ST12D, one IC is required. ST12D for encoding the signal, it is decoding the signal. And RF pair, this is the RF pair module I show you, and this is the motor driver L293D, and 9-volt battery required for giving the power to the motors, and battery connector, some connecting wire, and the robot body means chassis of the robot. And 7805, I also told 7805 is used provide the controlling signal, because our power is 9-volt and the controlling signal is 5-volt. So converting the controlling signal to 5-volt, we use this voltage regulator. Okay, and we also use the 750K resistor and 30K resistor, 1K resistor also. So this is my motor driver IC L293D. Using this IC, we control the two DC motors. The speed of the motor is control, direction of the motor is control. Okay, so it have a 16 pin. The pin number 1 and pin number 16 is giving the 5-volt supply, and the motor is connected to the pin number 3 and pin number 3 and pin number 16, pin number not 16, pin number 14. Okay, and the pin output will be connected to the out 3 and the out 4 also. And the pin number 8, it's provide the power supply, the 9-volt, 9 to 12-volt you can provide, and this IC will be work on the 12-volt to 24-volt. Okay, when you are going to the controlling the higher motor, so you use the other IC L298D. Okay, so it's basic, it's working on the 2 ampere current. When you use the more ampere, controlling the more ampere, so you can go the L2938. Okay, so this is the RF module. It is working on range 433 megahertz frequency, and the output power will be 4 to 16 dBm. Input supply providing the 3 to 12 volt. On the it have a VCC point and some ground point. Separate power supply to the receiver and the transmitter circuit. This is the circuit diagram of the RF module. Okay, means the transmitter circuit. So it use the 4 switches for controlling the direction, and it is a battery. This is the voltage regulator. It's convert the 9 volt into the 5 volt, and this antenna, when the signal is encoded, from the encoded bits, 4 bits are coming, it's converting the wireless signal. Okay, and the receiver circuit has also antenna, and it receives the 4-bit data and it's controlling. And it have a 18 pin. All the pin from 1 to 8 will be short, and it is connected to the ground. Okay, and the other pin number 18, it a pin number 18 is giving the 5 volt supply. It is a VCC pin. Pin number 17 is connected to the data pin, means the 4-bit data. When it connected, the 4-bit data provide to the transmitter circuit, and the transmitter circuit will be as a making a wireless signal to the transmitter. Okay, and VSS all are the grounded, and it that transmit module, it have 4 pin. One is the antenna, third one is a VCC pin, third one, and the second one is a data pin, and one pin number 1 is a ground, because it's use a separate power for provide making the signal, and the 4 switches are there. Okay, in the next slide, it is a receiver circuit. In the receiver circuit, we use a L298 controlling the power. It is a 12D for decoding the signal, and it had the pin number 1 to pin number 8, all are the short and connected with the ground. In the previous circuit, we also the all are the short and connected with the ground. So in the figure, the 4-bit data pin number 8, 9, 10, 11, it is a 4-bit data connected. Okay, the signal coming from the switches is AD8, AD9, AD10, AD11. Okay, so 4-bit signal coming in the receiver circuit, D9, D8, D10 or D11. Okay, it receives the signals for decoding, and it is signal sent to the L293D to controlling the motor. It connected to the, here you see, it connected to the pin number 2, pin number 7, pin number 10, and pin number 15 for controlling signal. And the motor will be connected to the 3, 6. One motor is connected 6 and 11 pin, and other motor connected 3 and 14 pin. Okay, and the pin number 8 provide the 9 volt, because we use the 9 volt power to give the motor. And this 9 volt battery using, and this one 9 volt battery is connected to the 7805 to making the controlling signal, because to the 18 pin we provide the 5 volt from, and we provide the 9 volt on the pin number 8, means we use the potential, means 5 volt and the 9 volt. And this LED is connected pin number 17 to the means pin. And if we talk about the receiver circuit, receiver RF module, it have 4 pin also, and it has 4 pin. It's total 8 pin. Okay, so both are grounded. Pin number 3 and pin number 2 are grounded. Pin number 1 and other pin number 4 is 5 volt VCC. Okay, so it connected to the VCC. Here you can see this one is pin number 1, and this is pin number 4 connected to the VCC. This LED show, it is blinking, means when your connection is stabilized, so it's blink, means your connection is fixed, your connection is coming. Okay, and this, when this is stopped, means that is safe, it's not working. Okay, and this register is connected to the 15 to 16 pin, 33K. In the last, it's 750K register. The 30K register will be connected, the 14 will be ground, and the left the pin are ground. Okay, so I will show you demonstration of this project. As I discussed, first we need a body of the robot. So this is the body of a robot. Okay, and we require the 2 DC motor. So these are the 2 DC motor. Two tires are there. Okay, now we are start to connecting all the things. The first of all we fix the motor both side, and after that we fix the tire of the motor. Okay, now my body is ready. Means you can say the chassis is ready. Base of the robo is ready, and now we are making the controlling circuit, the remote of the robo, and the receiver circuit of the robo. So we are started. I also told the basic remote circuit. I also explained all the things of that. So now we are making the robo remote. This is the same circuit I show you. Using this circuit, we make the remote on the breadboard. So now we are making a complete remote. Now we are going for the receiver circuit. This is a diagram of the receiver circuit. This one. This is L29D and this is STD. And this is our RF module. Now we start to make all the things. Now our body is ready and all the remote are ready and the receiver circuit is ready. So we are assembling all the things. These two connected the motor. Means I told you na, 2 motors are connected. So 2 controlling signal coming from the receiver circuit. Okay, I connected this and both the motor are connected.
Hello, sir. Hello, sir. Am I audible?
This is the antenna. It receives the signal from the remote and it control the 4-bit data.
Hello, sir. Am I audible?
And this one and this one, we connected the 2 battery, 2 9-volt battery.
Hello. It is not clear. Hello.
Now robo is complete.
Not clear to us.
Now it's time to demonstrate.
So your
So
voice
now you see how it works. You can make a forward from the switches. You can make a reverse. All the things of controlling of this robo, you can use a Bluetooth module and some other module are available for controlling the wireless signal. Okay, so from this is the our Bluetooth module. This one is our Bluetooth module. So controlling the Android phone, using Android phone, you can control the all the applications in your home, such as light, tube light. You can control on and off from your smartphone. And you also in the last lecture, Alok sir is also told how can you take a from real-time sensors, means it show the solar tracker and what is the value of the solar tracker, the voltage, how can it generate it, and it's reading on the smartphone. So using this is the SC05 Bluetooth module, and some other devices are also available such as a Zigbee. Zigbee has controlling the many, means it's not dependent. In the RF module we are require the 4-bit data, but from the Bluetooth module we require the more 10 motor are controlled easily. It using depend on the apps. Okay, so what is how many sensor will be controlled by the apps? So you use the Bluetooth module, you can control the many things. From Zigbee, you can control the Ethernets are also available for the wireless GSM module is available. So it's depend on the application what you want and what is implemented in your project. So basic things, all the basic things I show you. And this one, this is my make a small. चलना? Like I just. So this is IR based robot. Means when the some object are coming in the front of the sensor, it will be stopped. Okay. So this is you see that when the some object are coming, so it will be stopped. Now it running condition you call. Okay. Just run it. To show very clearly. You can adjust the range of this. This is our potential. So you can change the range of the distance. How means how much distance you take, and it will be stopped. Okay.
सेंसर लगा बंद करेगा देखो ये लाइन फॉलो है आ जाओ नहीं हमें उधर आ जाओ आ जाओ
मत बुरा यार बैठो बैठो
I make a switch here, and I also discuss in this. So we use in this robot two DC motor here. One motor is this, one motor is the two tire are there. This is our Arduino board. This pin is used as an input pin. When the some object are detected by the sensor,
लाइन फॉलोअर वाला जो
when the some object detected by the sensor, it's giving the signal to pin number pin number 9. Okay, and we connected a transistor circuit to this model for providing the switching transistor circuit with a register, such as it provide the controlling signal when we get giving the gate pulse. When we giving the base power on the base, transistor will be on, and it will be giving the controlling signal to the motors. Okay, so in the 9-volt battery is connected here also. Just show you the 9-volt battery for providing the power to the both motors, and the both motors are connected in the parallel, because when giving the power, it's going in the one direction, forward and the reverse. And when the sensor, this is the sensor, and when it detect, this is the detector in the sensor, this one is a receiver and this one is a transmitter. Okay, this one is making a signal and it attack to the object and receive this signal. This is the photodiode and this is a simple LED. Okay, to making these things, we are also developed on the breadboard. Also we are making this sensor on. Okay, using this sensor, this IC need, and making the use of some resistors and the capacitor, we can develop this. So these sensors. Okay, and the sensor is coming. So when the signal is coming from this point, I make a program of the sensor. And in the last lecture, Alok sir is also discussed how can blinking LED from the Arduino and all the basic things. Okay, so when we fix this pin as an input, and it is a digital signal coming from those, we are not required to connect it in the analog side. Okay, so we are using in the digital side also. Okay, when it is the analog signal, on the analog signal, that's why we are connected to the analog pins only. Okay, such as this is analog signal. When we connected this, we also connected in the analog pin, and this is the LDR sensor. When I connected this, it is also connected to the LDR, means the analog pin sensor also. Okay, so when this one is high, it's given to the signal to pin number 10, and pin number 10 is the base of the transistor. When we give the power to the base of the transistor, the switching will be on, and the motor power get to the motor, and your motor will be going to forward. Okay, so I told all the basic things from this, and I also making the switches here, and this is the switch to controlling the manually control to the motor. When we open the on it, and it's working. Okay, it's now working, and it is stopped. Okay, and this power is used when we use the Arduino as a programmer. So this cable, Arduino cable, programmer cable will be used. But when we is a dedicated application, so that's why we need a power source. So and this 9-volt battery giving the power to this Arduino 9-volt power, and using this cable we can fix it and using in some applications also. Okay.
I'll check with the
Yeah, no problem.
robot or the transparent like a glass. If they are object like a glass.
Yeah.
Then
Means actually it's depend on the object. If your signal is transmitted, means it's a distant. You vary the range, na? Okay. If you suppose these type of things, if the range is transmit, okay, so there are no, it's detect there are no object. Okay. Means you make a arrangement. It is a potentiometer, na? So you make arrangement first to check at the arrangement, then you use. Okay, and it is I also told that it is a 30 centimeter only. When you use a larger, that you use the other sensor also.
then what happens if there is a transparent object?
Yeah, I understand you. What do you say? This is the transparent object. Suppose this is the transparent object.
Okay.
It's a way go to high na, and it's no detector. It is there are no object. It is going on. Okay. Actually, it's totally depend on the this and this when you use the this sensor in the front of robo, when I make on this sensor replacing this sensor, it will be work. Means it's a distance. When I make a distance, suppose I make a program in the Arduino to going the 10 centimeter and come back. So how can calculate the time? By the this ultrasonic sensor. It's give the and how many take 10 is calculate the distance and it's come back. Okay, so all the sensor I discussed, and there are many other sensor are available in the market. So using these sensor, we are making the smart applications in the robotic also, home automations, door automatic open. You also see in the markets also and mall also, and you going to door will be open automatically. Okay, so using these sensor, we are making the many things. So I discuss the basic things. If you have any query, I am happy to answer your queries.
Let us ask.
Is the total number of sensors available, or you have just discussed important one?
Means
There are many
there are
sensors.
many sensors, man.
These are just a few.
Just a few ones. Means using these sensors means if I using 5 sensors or 5 IR sensor, we are making the line follower robot. Okay, it's detecting a one color. Next robot means the next sensor. If I use this sensor, okay, making the arrangement of the sensor, we can make many things. When we are develop a line follower robot, so we require the 5 IR sensor and fix it. And this sensor is follow the black line only, and there are black line. He detect the black line. It's giving the signal. Okay, so making the arrangement of the sensor, so it's will.
Let us contact the centers.
Robots are there which are sensing the light and the body.
Yeah, so it depend on the sensor which you application you use.
First center.
You have any query?
Madurai. Anna University Regional Center, Madurai. Any doubts you have?
Where will be that hands-on training?
Yes. Do you have any doubts? Yes or no?
No, we don't have doubts. Is there any hands-on training? Is there any hands-on training in this zone?
स्पीकर बंद की है.
Yes, Anna University.
Yes, sir.
Is there any hands-on training?
Hands-on training.
Yeah, we have some teachers are there in a innovative skill. In the last lecture, you are met with the Alok Deep. So we are making the team and provide a hands-on training also in the NITR, in the innovative skill. If you want to take a hands-on practice, you can come, and we are providing a workshop in your institute also.
You are interested in coming here, or you want them to come to your place now?
No, I'm asking, is there any hands-on training regarding this one? Because you are showing the demo only.
Yes, sir.
Yeah.
Saying you are showing only demos or is there
You are showing the demo only. That's why I'm asking, is there any hands-on training in this program, in this 5 days?
Sir, this is an ICT based course. How is hands-on training possible? In case you are interested in doing hands-on training possible, hands-on training, there is one course, STC Contact Mode program, in the month of July. You're most welcome to come here in Knitter and do the hands-on.
Yeah, okay, okay. Thank
In
you.
the ICT mode, we can only show the demo. Now, how will you do hands-on at your place?
Okay, ma'am. Thank you.
Okay.
So please move to the next center. RTU quota.
Am I audible, ma'am?
Yes, sir, we can hear you.
My question to sir. Yesterday we have discussed about programming of Arduino with the help of MATLAB.
Yeah.
Is there any ready-made module is available for 8051 programming with MATLAB?
Actually, Arduino is friendly with the MATLAB. Okay, you making some program on the fuzzy logic based, ANN based, because when we are training to the robo, when suppose we are making a develop robo, so you can make your rules in the fuzzy logic using the NN tools also and the fuzzy tools also. So you making the MATLAB file and it's easy to interface with the Arduino. Okay, Arduino is friendly, but it's difficult to connect with the 8051. So this is
So that is why we have discussed the various programming languages, which are used for 8051. For that, the most widely used one is is embedded C only.
So this is the problem with the 8051. When you use your applications, so you use the Arduino also. I also help to you with the interfacing of the MATLAB. No problem. It's when you make a fuzzy loading model and what you want in the MATLAB, it's also connected with the Arduino.
Okay, thank you, sir. For engineers from electrical engineering stream, it is not possible to learn C language.
Yeah.
Complex C programming for 8051 microcontrollers. That's
Sir,
why I am asking this.
Person, don't say that. I'm a core electrical person. I've been doing embedded systems since last 10 years. It's not, there is nothing like that electrical people cannot do C programming.
Actually, just for example, in MATLAB, we design, we make a model in Simulink. Means we go for model-based designing, and the code is automatically generated by MATLAB itself.
I told you, sir, is the easy way of the Arduino programming. Okay, but first to try it, there are some software are there, mblock. Okay, you are no need to write your program. You just take a block and you write a program. You just take a block and paste on your screen, and using these blocks you can make your program. You are no need to read deeply the C programming also.
No. Actually, what he's saying is that for Arduino it is possible. Yeah. So it's such kind of thing is possible for 8051 also. This is his question.
Okay.
For 8051, you'll have to learn C.
Okay, thank you.
Any other questions, sir? Any other? Okay, next end.
One more question, ma'am.
Anji. Yes, sir.
Sir, can you explain the LCD code for that you used?
Actually, this is I show you.
Sir, LCD on Thursday in the morning also I told. On Thursday in lecture I will tell you the whole interfacing part along with the C code also. Thursday morning lecture.
Thursday morning.
Next set.
Thank you.
Okay, sir. CIT? Surendra Group? Yes, ma'am. Any doubts?
No, ma'am, no doubts.
Okay, thank you. PIT? Panipat Institute?
Hello.
Yes, sir.
My question is how range of ultrasonic sensor?
This one is the ultrasonic sensor.
Yes.
Just a minute.
How can set the range of ultrasonic sensor? How can set the range?
How to set the range? That is his question.
Actually, this is the ultrasonic sensor without changing the range. Many ultrasonic sensors are available in the market with fixing the range. You can check on the online also. The means arrangement of the range you can purchase from the online also. Okay, but this sensor is not changing the range. This one is not changing that. This range is fixed. This is a 400 centimeter. I told in the when I show the PPT, in the PPT I show you this range is 30 centimeter to 400 centimeter only.
In market, there is any manual sensor, sir?
Yes, sir. What is your question?
In market, there is any manual sensor, sir? Manual. We can change the range of ultrasonic.
Is there any
there is only fixed sensor.
Manual available.
Means sir, I told na this is IR sensor. You can make one. Means आप
he is asking कि इनके साथ कुछ manual भी आता है क्या?
Yes,
No.
sir, manual.
नहीं.
This is no manual, but all the working of this sensor are available on the net. Now, how can you use? It have only 4 pins. In this sensor, there are 2 pins. 2 pins are using for the giving the power to the sensor. One is for analog read, one is for the digital read. Okay, the sensor have a 2 reads. The digital when your signal is analog form, when your signal is digital form. So you can take it the input only. So this is no manual are there because it's giving the power and take the input on.
Thank you, sir.
Welcome.
Okay, thank you so much, Mr. Anurag and Mr. Chandan. They have explained the various sensors like ultrasonic sensor, IR sensor, flex sensor, and which other sensor have you discussed?
Yeah.
PIR sensor also. Then he showed you some applications based on 8051 as well as Arduino programming, and wherein LCD interfacing was done. Then one wireless robot also you can design using these sensors. And in the Thursday's lecture, I'll show you like today we have seen how to convert the C hex file from the C file. On Thursday's lecture, I will tell you how to actually burn into the microcontroller, and some interfacings are also pending. For example, LCD interfacing, its C code, etc. All these things I will be demonstrating to you on Thursday lecture. So thank you so much, both of you.